of systems and games. If you want to see a clear example of the power of interface, you can go watch my How to Interact with NPCs video. That video takes advantage of interface to make sure that the player can interact with any kind of object. Alright, so thanks to interface, we can now change the parent of the kitchen object and put it on either a counter or the player. Now in the next lecture, let's make a proper different counter type. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a different counter type from where we can grab some ingredients. Okay, so far here we have our character working and we have an empty counter, and by interacting with it we can spawn an object. But obviously that's not the behavior we want in the final game. We want different counter types that do different things. The clear counter should only be used as a place for putting down and grabbing objects. It should not spawn anything. So let's build a new counter type. And for that, one option is to make a brand new prefab and build it all from scratch. Another option is we can duplicate this counter and change a bunch of things. Or there's a third option that was added in recent Unity versions. You can now have what is called prefab variants, meaning that we can have a base counter and then we can make variants for all the types. So let's do exactly that to learn about prefab variants. Now first, let's duplicate this one just so we don't lose any changes. Let's rename this prefab to _base counter. Now I like to add an underscore just so that the base prefab is on top, since this window is sorted alphabetically. Now let's go inside the base counter. Let's go into the scene view, so here it is. And basically over here, we only want to have all of the things that all of the counters will have. So all the counters will have a box collider, all with the same shape, so that's good. They will also all have a counter top point. However, for the visual, different counters will have different visuals, so let's get rid of this. Same thing for the selected, let's get rid of this. And on the actual object, different counters will have different scripts. So let's also get rid of this. Okay, so that's it. This is the base counter. It only has all of the things that every single counter will have. So let's go ahead, save this prefab, go back outside. And now let's right click on the base counter and go into create. And over here, let's scroll down and find the prefab variant. Now let's name this the clear counter, except obviously we can't have two different names. So let's put this one into backup. We're going to get rid of this one in a little bit. So on the variant, let's name it clear counter. Let's open up this variant. And now here, let's add everything just like we had on the old clear counter. So since it's going to be exact, let's actually go inside the backup one. So here, let's just copy the visual and the selected. So let's copy this. Go back inside the clear counter variant. And over here, let's paste it. So Control V. So there it is, the selected and the visual. Finally, just a script. So over here, let's add the clear counter script. And now let's just drag the references. So the kitchen object, we're actually going to remove this in a little bit, but for now, let's assign it. The counter top point, let's drag it. And on the selected, we also need to drag the kitchen counter reference. Okay, so here is our clear counter as a variant of the base counter. So let's go ahead, save this and go back outside. And now we can finally delete the old prefab of the clear counter. So let's go ahead and delete this. And of course, over here on the scene, we've got some broken prefabs. So let's get rid of both these. And let's drop the clear counter variant. So let's drop it, place it over here. So let's put it on X of 0, Y of 0, and Z of 3.5. Okay, so that's the clear counter. Let's just put another one to the side and perfectly on the side. So on an X of minus 1.5. Okay, now we can begin making our container counter. So for that, once again, let's make a variant. So right click on the base counter, go into create, and let's create a prefab variant. Call this the container counter. And let's go inside of it. Now here, first thing we need is the visual. So let's go inside our assets. We've got the prefab visuals. Inside we have the counters visuals. And let's find the container counter. So let's drag it inside. Again, for the local position, make sure it's all on 0, 0, 0. Okay, great. Then we need to make the selected. So let's duplicate this visual. Let's rename this to selected. Let's go inside on all of these. And let's modify the material for the selected material. So let's click on the circle icon and select the counter select material. Okay, we've got our nice little ghost icon. And just like we did previously, let's start with these disabled. So all these game objects disabled, so they are hidden. And on the selected, let's make sure the scale is 1% bigger, so 1.01. Also on the selected, this one does not need an animator, so let's get rid of this. Now let's add the selected counter visual. And obviously for this one, we're eventually going to need to refactor it to support multiple visual objects. As you can see, this selected has multiple. But for now, just make sure that it works. Let's just drag just the first one. Okay, great. So our container counter has been built. The only thing that we need is the main logic script. So let's do that. Let's go into our script folder. Let's create a brand new C# script. Name it the container counter. And let's select the main game object, attach a script, and let's open it. Alright, so now here let's first think what we want. For this counter, we want the player to interact with it, and when it does, we want to spawn an ingredient and give it to the player. So that means that we're going to want pretty much the exact same behavior that we made over here on the clear counter. So when the player interacts, we spawn and we give it to the player. So let's actually copy all of this code. Let's go into the container counter, and over here let's paste this. We just need to grab the references to the kitchen object and the kitchen object SO. So again, just like we did on the container counter, let's copy all of these references. And over here, let's paste all of them. And of course, here we have an error. In order for this to work, this needs to implement our interface. So let's do exactly that. So let's implement the iKitchen object parent. And back in the clear counter, let's just copy the exact same code. So all of these functions, let's just copy them. And on the container counter, just paste them. Okay, great. So we don't have any more errors here, so everything should work. We should be able to interact with the container counter, and we should be able to see an object being spawned on top of it. Over here in the editor, let's just make sure to assign it. So let's assign a default kitchen object. So let's say a tomato, and the counter top point. Let's drag the reference. And okay, everything else should be working. So over here on the selected, we've got the visual game object, and on the container counter, we've got this. Okay, great. So let's go outside into scene view. And over here, let's just place some container counters. So let's drag one up there. Let's place it on an X of 1.5, on a Y of 0, and Z of 3.5. And let's also place another one down here. So let's rotate it to face it upwards. Okay, so on position 0, 0, -5. Okay, great. And let's make them spawn different things. So on this one up here, let's actually spawn a cheese block. And on this one down here, let's spawn a tomato. So let's also modify the icon here. So from cheese block, and let's put a tomato icon. So here it is. Okay, we've got two counters and two clear counters, so let's test. So here we are, and if I approach the container counter and I press the interact button, and nope, nothing happened. We cannot interact with it at all. Even the selection visual, even that one is broken. So as I approach, nope, the visual is not showing up. Now the reason for this is actually pretty obvious. If we go over here on the player script, down here when we're handling our interactions, so let's go into the handle interactions function. Over here we are doing a raycast, and we are trying to get component of type clear counter. So basically we're not doing anything if that object has a container counter instead of a clear counter. So again, we have a similar issue to the one that we had in the object parent logic. Basically we have two types, a clear counter and a container counter, and we want the player to be able to interact with both of them. So as a solution for this exact same problem, we could also implement an interface just like we did. That would work, that would enable the player to interact with multiple counters. But in this case, since the counters are all very similar, very related objects, they're all going to be kitchen counters as opposed to object parents where the player and the counter are completely different. In this case, since they are all very similar, a better approach is actually to use inheritance. Now here, I should point out that inheritance is one of those things that is simultaneously very powerful but also very dangerous. Usually beginners get really excited when they first hear about inheritance, but after gaining some experience they start to see the massive downsides. One funny joke about it is, let's say you want to write some code that all it needs is a banana class, but because of messy inheritance you end up with a monkey and the entire jungle behind it. Basically the banana extends a monkey, which extends a tree, which extends a jungle, and so on. So you just want a small thing, but because of a complex inheritance you end up picking up a huge object. So all of that to say, inheritance is something you must use very, very carefully. It's a powerful tool, definitely, but you need to make sure to absolutely use it in the right approach for the problem you're trying to solve. Now in this case, like I said, since all of the counters are going to be very closely related, in this case it does make sense. And of course in the future, if that does change, we can always refactor. If you're a beginner, definitely go ahead and research a bit more on C# inheritance, the pros and cons. I don't have any dedicated video on that topic myself, but if you search, I'm sure you'll find tons of content. Again, it's a very powerful but also very dangerous tool, so definitely use it wisely. Over here, let's make sure we're wise, so let's use it. First thing we need to do is define the base counter class, so let's create a new C# script. Let's call it the base counter. So over here on the script, let's get rid of the functions. We don't want any default functions. And let's also make sure that we do extend mono behavior. We do want that. We still want to use this as a component. So let's leave the script just like this. Let's save it. Then let's go over here into the clear counter script. And on this one, instead of extending mono behavior, let's extend the base counter. Okay, that's it. That's the only change. And now let's go into the container counter. And over here, same thing. Let's extend the base counter instead of mono behavior. So now both these counters extend the exact same base counter script. So now if we go into the player script, so here we are on the player script, and on the handle interactions function, over here, instead of trying to get a component of type clear counter, let's try to get the component of type base counter. So let's also rename this, so Control RR to rename this to base counter. And of course, we need to rename all these references that expect a clear counter instead of a base counter. So over here for the selected counter, let's modify the type to base counter. Then also up here, when we've got the event args, let's modify the type, okay? So over here we have the interactor. Let's leave this for a bit. Let's go down and let's fix this issue. So let's go down into that function to set the selected counter. Instead of this type, let's receive a base counter. Okay, so all of these errors have been solved. There's only one left, and it's this one, the interact. We see this error because obviously the base class does not have any kind of interact method. So let's add that. Now for adding methods to a base class, it's actually very simple. It's really just like any other method. So first the accessor. For the interact, we want the player to be able to access it, so let's make it public. And also, since we're talking about inheritance, I should probably mention the other accessor. Now you already know about public, and you also already know about private, but there's another one you might not know, which is called protected. Basically, this one means that whatever function we define with this accessor, it is going to be accessible to this class and any class that extends it. So for example, if we had a function that was protected, the clear counter could call this function because it does extend this base class. However, the player would not be able to call this because it is protected. Now in our case, for the interact action, we do want the player to call it, so let's make it public just like we had previously. Then another keyword. For every function that we want the child classes to be able to implement in their own way, we can define it as virtual. And finally, the function signature as normal. So for the interact, we made a return void, call it interact, and we received a player argument. Okay, so that's it. That's our basic signature. For the implementation, let's leave it empty over here on the base counter. So by default, it's not going to do anything. In the game design that we're building, we're never actually going to end up with anything like this. So if we want for safety, we can just add a debug.log error to say just base counter.interact, because this should never be triggered. Also, I should point out, for a more advanced method, instead of making it virtual, you could make it abstract. And basically what that does is that forces all of the classes to implement their own implementation. So you would make this abstract and just put it just like this, as if this were an interface. But in doing so, you would also need to define the base counter as abstract and so on. So basically this is a more advanced method, so don't worry about it for now. Let's keep it a bit more simple. So let's make it just virtual void interact. Okay, great. So we have this, let's save this. And now if we go on the clear counter, over here on the interact, notice how we have a green squiggle line. Basically this is a warning, it's telling us that we are hiding the base function. Now in reality, we don't want to hide it, instead we want to override it. So before the void, before the return type, we just add the keyword override. And yep, this will now override the base function. So when the player interacts with an object of type base counter, and that object is actually a clear counter, when the player calls the interact function, instead of running this code, it's actually going to run this code. Now let's do the same thing on the container counter. So over here, let's also add the keyword override to override the base function. Okay, great. So we have no errors here. And on the player, we also don't have any more errors since that one does now implement the interact function. So with this, let's test and everything should still be working. So over here, let's approach the interact counter and let's interact with it. And yep, it does work. It spawned some cheese. And down here, yep, it spawned a tomato. And then if we go onto the empty counter and interact, and yep, it still works. Okay, so here we added the ability to interact with two different counter types. All right, great. Now note how the selected logic isn't really working well. You can see the container counters, they are both selected, even though the player is not looking at them. And actually, if I approach it, then it actually becomes deselected. Basically, the reason for that is because the selected script, that one is still referencing the clear counter instead of the base counter. So right now, it's only being selected when the selected counter is null. So that is why as I approach, it actually hides itself. So let's fix this. Let's go inside the container counter prefab, and inside we've got the selected. And yep, over there we have a reference to that. So let's open up this script. And over here, all we need to do is just modify this type. So let's make it of type base counter. And let's rename this to base counter. Okay, that's the only change we need. And by the way, since we're here, let's also fix the other issue. The issue we had where we need to support more than one visual game object. So instead of having a field of type just game object, let's receive a game object array. So let's modify this to game object array. And then down here on the show hide is actually very simple. So let's just do a for each game object for the visual game object. In the visual game object array, we go inside, set it to true, and on this one we set it to false. Okay, that's it, super simple. Now let's just update the prefabs. So first over here on the container counter, let's drag the container counter reference as the base counter. Okay, great. And for the visuals, let's just drag all of them. So let's drag the counter solid, drag it on top, then the counter hole, drag it on top, then the single door, drag it, and the black, drag it. And also, by the way, over here on this counter, this one actually has an object sprite. This is the actual sprite in there, but for the selected, we really don't want that. So if I enable this game object, here we've got the object sprite. Let's actually delete this. We don't need the actual icon sprite to be highlighted, so let's leave it just like this. So we only have these 4 objects, and all 4 of them are on the list. Okay, that's great. So all the references in here, they're all working perfectly. So let's go back outside, let's save the prefab, let's go inside the empty clear counter. And on this one, same thing, on the selected, let's drag the insider reference. And for the base counter, let's also drag that reference. Okay, so let's go outside, save it, and let's test. And now let's see if the selected works. So as I approach this one, yep, it works, yep, it works. And on this one, yep, it works. And down here, yep, it works. All right, awesome. So we can interact and we can highlight our selection. Okay, everything is working great. So now that all of the code is working, we can inspect the code to see if we can refactor anything. We can see, for example, if there's any kind of common logic that all of the counters share that we should probably write in the base counter. And you can see right away that both the clear counter and the container counter, both of them implement the kitchen object parent interface. That behavior is something that all of the counters will share. So instead of defining it on each counter itself, let's actually do it on the base class instead. So let's get rid of the interface implementation here, and also on the container counter, let's get rid of that. Instead on the base counter, let's implement that one. So I kitchen object parent, and for the functions, let's do the same thing. So let's cut this one from here, and let's paste it on the base counter. So okay, now we need these 2 points. So let's go ahead, copy all of this. Let's go into the base counter, paste it. Except for the base one doesn't need a kitchen object so just the counter top point and the kitchen object. Okay, so there are no errors on this one. Let's go into the container. Let's get rid of the kitchen object and the counter top point. Okay, great. Now we see an error, but before we worry about that, let's actually go into the clear counter and let's do the same thing. So let's get rid of this, get rid of this, and down here, get rid of all these functions. Okay, so now the counter scripts are much more simple. All of the common code is now written directly on the base counter. Now for solving this, the container counter needs to know if there's a kitchen object on top of it. So now here we have an interesting question with 2 possible approaches. Basically, we need access to this object. So one approach would be to make this protected. Like I said, protected means that any classes that extend this base counter class, any of those classes can then modify that field. So like this, yep, there's no more errors. That's one approach. And the other approach is to instead keep this one as private. And whenever we want to interact with it, we simply interact through these functions. Both approaches can work, and when in doubt, as usual, you should probably go with the more limited option. So let's leave it as private and work with these functions instead. Over here on the container counter, instead of testing if the kitchen object is null, let's just test has kitchen object. So if it does not have a kitchen object, then we're going to spawn it. And for spawning over here, we could grab the actual transform follow. So this one up here, we could call this function to get it, or since that is actually going to be handled automatically when we call this function to set the parent, then let's actually not use this at all. So we just spawn it and set the kitchen object parent. Okay, great. So now let's just look at the clear counter. For this one, like I said, it's not really meant to spawn anything, so let's actually remove all of this code. This one is only going to serve to pick up and drop items. We're going to handle that in the next lecture. But for now, let's just go back into the container counter and let's do the proper logic that I mentioned in the beginning. Basically on this one, we want to spawn the object and we want to immediately give it to the player. So when we call setKitchenObjectParent, instead of passing in this, let's pass in the player reference. And that's really it. For the container counter, this is all we're going to do. So the player interacts and it spawns an object and gives it to the player. Okay, so that's it with this. As you can see, the code for all of our counters is much more simplified. So basically it only handles the logic related to that specific counter. Everything else is on the base counter. So let's test this. So here we are, and if I approach the counter and interact, and yep, there you go, spawn some cheese and gave it to the player. Okay, great. Now, just for fun, when I made these assets, I actually included a nice animation. So if you go inside the container counter, over here on the visual, note how this already has an animator with an animator controller attached to it. You can double click to open it up. And over here you can see it's very simple. Basically just has two animations. One is the container close and one is the container opening and closing. These transitions are basically triggered by this parameter. This is a trigger parameter. So when triggers goes into the open close, and when this one ends goes back into close. So let's just quickly add these nice animations. However, again, as usual, let's make sure to write some good clean code. So let's not add the visual over here on the logic script. Instead, let's make a proper new script. Over here, let's create a new C# script. Call this the container counter visual. Okay, now we want to attach this only to the visual game object, so only this one let's attach, okay. And over here, the first thing we need is to get the animator. So let's sort a field for the animator, and since it's on the exact same object, we can just make an awake and get component of type animator. And we just assign this field, okay. So with this, we have the animator. Now we just need to know when we should play the animation. So let's go over here on the container counter script, and basically let's make an event that we're going to fire when the player grabs an object. So let's make a public event of type, let's stick with the standard, so let's use event handler inside using system, okay. Let's name this on player grabbed object. And then down here, when the player interacts and gets an object, let's fire off this event. So invoke, let's invoke with this an event args.empty. Okay, so we are firing off this event. And over here on the visual, first we need the field for the container counter, so let's add it up here. Let's add a serialized field of type container counter. Okay, we have this field. Now let's listen to the event. But again, we're accessing an external reference, so let's make sure to do it on start and not on awake. So let's go into this one and listen to the onPlayerGrabbedObject event. Okay, so here we have the event. And it's over here that we want to access the animator and call setTrigger in order to play the animation. Again, when working with animator parameters, suddenly we do need to use strings. There's no way around that, but at least we can make it a bit more clean by defining a constant. So up here, a private const string, call it open close, and let's make sure to use the exact same parameter name, so open close. And then down here on the setTrigger, let's call this trigger. Okay, so that's it, some very simple visual logic. And now over here inside the prefab, all we need is to drag the container counter reference, so let's drag it. Also make sure that it has the animator and the animator controller. So with that, everything should already be set up. So let's go back into the scenes, save the changes, and let's hit on play. So here we are, and if I go towards the tomato and interact, and if there you go, it plays a nice little animation. All right, awesome. Okay, so here we created a brand new counter type, and we refactored our interact code to be able to interact with any counter type. The player can interact with the container counter to pick up an object. Now, the next obvious thing that we need is to enable the player to drop an object on the clear counter, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to enable the player to pick up and drop objects. Okay, so we already have the player working. I can approach this container counter, interact with it, and yep, the player picks up something. Now that's left is being able to approach a clear counter and being able to drop this object, so let's do that. Let's go over here on the clear counter script, and when we interact with it, we're going to do a bit of logic. First, let's just check if this counter is empty, meaning if there's no kitchen object on it. So let's test if has kitchen object, or if not. So let's say if we don't have a kitchen object, then there is no kitchen object here. And if not, then there is a kitchen object here. Okay, these are the two valid options. So if there is nothing here, then let's check the player itself. So we go into the player and we can ask the same question. So has kitchen object. So if the player is carrying something, so over here the player is carrying something. If so, then basically we just want to drop that object from the player and drop it in here. So that's very simple. We just go into the player, we get the kitchen object that the player is holding, and we just modify the kitchen object parent onto this object. Alright, so that's it. Just with this, it should already be working. Let's do a quick test before we handle the rest of the interactions. Okay, so here moving the player, and if I just interact with the clear counter, and nope, nothing happens. Okay, great. Since the player is not carrying anything, nope, nothing happens. Alright, great. Now let's pick up something from the container counter. Okay, so now the player is carrying a tomato, approach the clear counter, press the button, and yep, there you go, there it is. Alright, awesome, everything worked. Now this is an excellent point to know just how easy this was to implement. And the reason why it was so easy was because we focused hard on writing some good clean code for how the object and the parent system works. Because we took some time to think about that, it was now very easy to implement this brand new action. So this is a very, very clear example of the power of writing good clean code. Okay, so with that now let's implement the rest. So over here there's no kitchen object here and the player is carrying something, but if not we've got the else, so player has nothing. So if the player doesn't have anything, so let's not do anything. So player not carrying anything. So those are all the possible states up there. And then down here, if there is a kitchen object on this clear counter. If so, then let's check if the player has a kitchen object. So in this, the player is carrying something. And if not, then the player is not carrying anything. So basically, if there is a kitchen object here and the player is carrying something, if so, then we don't want to do anything since we can't give the player 2 items. However, if there is a kitchen object here and the player is not carrying anything, then we want to give it to the player. So let's just get the kitchen object, the one that is on this clear counter. And let's do the exact same thing. So set the parent and set the parent onto the player. Okay, so that's it. As you can see, some very simple logic. So let's test. Okay, here we are, and if we interact, nope, nothing happens. Okay, great. Now pick up a tomato, go there, drop it, and yep, there it is. Now if I interact again, yep, there you go, I picked it up again. So I can go somewhere, pick it up, drop it, and everything works perfectly. All right, awesome. Now the last thing that we need to fix is the container counter. Right now it's giving out an object every time, even if the player has something. So if I pick up, yep, it works. Now if I pick up again, there you go, we've got our nice harmful error. This should never happen. So let's set some nice checks. So over here on the container counter, okay, we have our interaction. And before we spawn anything, let's just see if the player can pick up something. So once again, very simple. Let's just go into the player and we check, does the player have a kitchen object? If so, we're not going to give it anything. But if the player does not have a kitchen object, then yep, the player picks it up and we give it the object. Okay, so that's it. It's this simple. Let's test. So here we are, let's pick up some cheese. Okay, great, now pick up another one, and nope, nothing happens. Okay, great, we're already carrying something, so we cannot drop anything. Now drop it in there, now pick up a tomato, and yep, it works. I can pick it up, drop it, and yep, everything works. Okay, great. Let's just do one more thing. Over here, the container counter is spawning the object, and the object is the one that we assigned. So over here in scene view, we've got the container counter. This one is placed on the scene, and we made an override to spawn a cheese block. Technically, we could keep doing this. Pretty much just duplicate objects, modify the sprite, modify over here the kitchen object. That would work. But another better approach would be to simply make some prefab variants. And yep, that does work. You can make a variant of a variant. So let's do exactly that. Over here on the container counter, let's right click, go into create, let's create another prefab variant. And let's say container counter, this one will be the tomato. Now let's go inside the prefab. And over here, make sure it has the kitchen object for a tomato. Okay, great. And over there on the sprite. So let's find the object sprite and choose the tomato sprite. So there you go, this one. Okay, let's exit and save. All right, now once again, let's right click on the container and let's make yet another one. This is going to be the one for the cheese block. So let's go inside of it and over here, modify it for the cheese block. And inside the actual visual, let's modify the sprite, and it's actually down, so the cheese block. Okay, great. Let's go back outside. And since we're here doing this, let's make all of the other grabbable objects from the containers. So let's first make the kitchen object SO. So let's go over here. We can right click, go into create new kitchen object SO. Let's make one for the bread. Then let's duplicate this one. We're going to have a cabbage, and finally we're going to have the meat patty uncooked. Alright, so now let's make sure to assign all the data for all these scriptable objects. First we need to make the actual kitchen object, so let's duplicate tomato, name this one bread, let's go inside of it. And first for the kitchen object SO, let's make sure to drag the correct one. Okay, there's the bread. And for the visual, this one is not a tomato, so let's go inside our visual assets, inside the prefab visuals, let's pick up the bread visual. Okay, there it is. That's all we need, so let's go outside, save the changes, and then select the bread scriptable object, drag the prefab reference, okay? For the sprite, this is the bread, and finally just call it bread. Okay, let's do the same thing for the other one. So next up for the cabbage, let's do the cabbage, drag the cabbage scriptable object, let's go inside and modify the visual, so the cabbage visual. Okay, that's it. Then on the cabbage scriptable object, drag the reference for the prefab. Let's assign the sprite and finally give it a name, cabbage. And finally the meat patty uncooked, so let's do that one. So let's duplicate it, name it meat patty uncooked. Let's go inside, modify the kitchen object SO for this one. And for the visual, let's select, here it is, the meat patty uncooked. Okay, let's go back outside. And on the scriptable object, let's just drag the prefab, assign the sprite, so this one is the uncooked, so it's this one. And finally, meat patty uncooked. Okay, great, so we added all of these scriptable objects. We also have the prefabs with the visuals and the logic script. Now let's just make the container counter, so once again, let's create another variant. So prefab variant, this one is for, let's say for the bread. Then let's make all the other ones already. So let's go make another prefab variant. This one is going to be for the meat patty uncooked. And finally, another variant. Also here, make sure you're creating a variant of the container counter. Don't make an accident of creating a variant of something else. So let's make another variant, one final one. And this one is going to be for the cabbage. Okay, we have all the variants. Now let's just assign them. So let's go inside the bread. And over there, modify the scriptable object for the bread, and for the icon, modify for the bread icon. Okay, let's go to the cabbage, save the changes, modify that one for the cabbage, go into the icon and modify the icon, and finally the meat patty uncooked. Let's go ahead, modify this one for that one, and the icon, put it on that one. All right, everything is working. Now let's just place them over here in our scene. So let's get rid of the ones that we made some overrides. So let's get rid of that container counter. Instead, for that one, let's drag the cheese block, put it right in there. Let's put it on X of 1.5, Y of 0, Z of 3.5, okay. Then down here for this one, let's put the cabbage next to it. Let's rotate it to face upwards. So like that. Let's put it on X of minus 1.5, Y of 0, and minus 5 on the Z. Then for tomato, let's get rid of this one and use the proper tomato one. So let's rotate it, put it on X of 0, Y 0, and minus 5. Okay, next we want some bread. So let's put the bread up here on the left side. Let's put it on X of minus 3, 0 on the Y, and 3.5 on the Z. And finally, the meat patty uncooked. Let's put it over here a bit more on the side. Let's put it over here on X of 7.5, 0, and 3.5. Alright, so we have positioned all of them. Let's just make some more clear counters so we can actually place the objects. So let's put this one over here on minus 4.5, this one over there. Let's also put some counters, let's say one on the right side, and a bunch more down here. Let's rotate them upwards. Let's put this one on 1.5, minus 5, and one more over here on the side. Okay, great. So we have all of our container counters as well as a bunch of clear counters. So let's test and make sure that everything works. Okay, so here we are. Let's go down, pick up a tomato. Yep, there's a tomato. Now a cabbage. Yep, there's a cabbage. Now some bread. There's some bread. And some cheese. There's some cheese. And some meat. And yep, there's some meat. All right, awesome. Everything works. So with this over here, we added the ability to pick up and drop objects on an empty container and spawn them from all kinds of container counters. Now in the next lecture, let's build a counter we can interact with in a very interesting way. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a cutting counter. So this is going to be a counter where we can place an object, like for example a tomato, and after doing a secondary interaction, we can slice it. However, before we do that, let's just fix one slightly annoying issue. So right now the player is walking around. Okay, that's great. I can approach a counter and interact with it. That's great. However, if I approach a counter from the side, look how the player is pointing towards the right. And if I press the W key, I can indeed select it, but the player does not rotate to face the counter. So that's just a minor visual issue, but still I'd like to fix it, so let's do that very quickly. Basically, the issue is over here on our player script, so we scroll down and find our handle movement function, okay? So here we were doing a bunch of capsule casts in order to fix the problem with the diagonal movement. So you try to move in one direction, if not, try to move in just one of those. And if we can move, then we assign the move direction and then move it. Basically, the problem that we have here is that if I press W to face towards the counter, then over here when we do this logic, so it's going to first attempt the X movement only, and the X is going to be 0, so the move there X is going to be 0, 0, 0, so it won't actually move anywhere, which means it won't be able to move. So this one becomes true, which then sets the move direction to 0, 0, 0, which then down here when we have our rotation, it's not actually going to rotate to anything. So we want the player to still not go through any objects, but we only want to modify the move there over here if we actually move in any of these directions. So the solution is actually super simple. So over here for the can move, we can move if there's nothing on there, and if the move direction.x is not 0. So that's really it. If we are attempting to move in the X at all, and if there's nothing on there, then we can move, which means we then assign the move direction. If not, then we don't touch this. And same thing down here. So we can move if there's nothing on it, and if the move there.z is not 0. So that's it, just this one simple change, and now the player should be able to rotate. So here we are, and if I look over there, and the player is currently looking to the left, and if I press W to point towards the container counter, and if there you go, the player does rotate a little bit. So that feels a bit more natural. Alright, so that's just a tiny visual thing that I wanted to fix, okay, so let's keep going. Now let's handle the actual cutting counter. So first of all, as usual, let's make a counter variant. So let's right click on the base counter, create a new prefab variant, call it the cutting counter. Let's go inside of it. And over here, first thing we need is the visual. So let's pick up from the assets the cutting counter visual. So here it is. Then we need the selected. So let's duplicate this one. Let's rename this one to selected. And on the animator, let's get rid of it. And instead add the component, the selected counter visual. Okay, great. Now let's drag the visuals for the visual game object array. And by the way, here's a quick tip. On the right side on the inspector, you can see this nice little lock icon. So if you click on it, then that means this inspector will not change as you select other objects. So I can click on and select something different, and this one does not change. It is still showing the selected object. Now this is useful when you want, for example, to drag multiple things. So you can lock the inspector, then the hierarchy, you can use shift click to select multiple objects, and then just drag them all directly inside the array. That's it, just a nice quick tip. So everything is done, let's unlock it, there it is. Okay, so that's it. Let's just assign the selected material. So the counter selected material, let's make it just 1% bigger. So let's select them all, 1.01, okay. And let's start with all of them disabled. Okay, so the basic setup is done. Now let's make our script to run this. So let's go down, let's create a brand new C# script for the cutting counter. Let's select the parent game object and attach the cutting counter, and let's open. Now here, as usual, instead of all this, let's start off by extending the base counter, okay? Once again, thanks to how we set things up using such clean code, this is pretty much all we need to make a counter. With this, the counter already works as a counter. Then next thing we need is to customize any logic specific to this counter by just overriding the interact function. So that's it. Now over here, we can put whatever logic we want just for the cutting counter. And for this one, for stars, it's actually going to be just like the empty counter, meaning we're going to be able to drop objects on this. So let's just go directly into the clear counter. So here it is. And let's just copy all of this code, go into the cutting counter and paste it. Okay, so the exact same logic. So checks if there's a kitchen object or not, checks if the player is carrying something or not, and picks up or drops it. With this, let's do a quick test just to make sure this one is working exactly like the clear counter. So over here, let's just make sure to drag the last references. So on the cutting counter, let's make sure to drag the counter top point. So drag that reference. And then on the selected, drag the cutting counter reference. Okay, everything is good. Let's exit this prefab. Make sure to save all the changes. And over here in the scene view, let's place one of our cutting counters. So let's paste in right in there. Let's put it on X of 4.5, 0, and 3.5. Okay, so let's test. Alright, so here we are. Now if I approach and I interact, nope, nothing happens. Okay, great. Pick up some cheese and drop it on there, and yep, there it is. I can pick it up, I can pick up some bread, drop it, and yep, everything works. Okay, so far so good. Now the next goal is to use the knife and actually slice the object that is on there. And for that, the first thing that we need is we're going to need a different input. Right now we only have the movement and the interaction, so let's add another alt interaction. For that, let's go into our input action, so let's open it up. And over here, let's make another action. So create a new action, call it interact alternate. And for the binding, let's put it on another key. So let's listen, and I think on F makes sense. So let's go ahead, select this one. Then as usual, let's make sure to save the asset, which in turn is going to generate the C# class and compile the code. Okay, great. Now we can go here into our game input class, and let's do the exact same thing we did for the interact action. So first of all, let's listen to it. So let's go inside the player input actions, inside the player action map. So this one is the interact alternate, and let's listen to the performed event. Okay, and when we have that, let's fire off an event, pretty much the same thing. So interact alternate action. And down here, let's just fire off this event. So let's invoke using this and event args.empty. Okay, so we have the input for the interact alternate. Now let's go on the player to listen the same way we were listening to the regular interact action. So over here on the player script, let's see how we're doing things. So we go into game input and listen to that. So let's do the same thing, game input and on interact alternate action. Let's listen to this one. And when this one happens, let's do pretty much exactly the same thing, except we're just going to call a different function. So instead of interact, let's call interact alternate, which in turn obviously means we need to define this function. So let's go into our base counter. So here we are on the base counter, we've got the interact, and let's make another one exactly the same, just a different name, interact alternate. Okay, that's it. And now we are only going to implement this in the ones that need implementation. So for example, on the cutting counter, over here, let's override that one. So public override, and let's override the interact alternate. And now here, let's check if there's something placed on here. So if there's a kitchen object placed on this counter, if so, then let's basically cut it. And for cutting it, the simplest way is really to destroy whatever object is on there and just spawn the slice object. So let's handle destroying a kitchen object. For handling that, let's go over here on the kitchen object script. And let's make a simple function for this object to destroy itself. So let's go up here, make it public, return void. And for the name, I like to use the name destroy self to make it destroy this object. And really all we need to do is just destroy and call destroy on this game object. However, before we do, let's make sure to clear the parent. So let's go into the kitchen object parent, clear it, and then destroy the game object. Okay, that's great. It's really this simple. And then on the cutting counter, let's get the kitchen object that is on here and tell it to destroy itself. Okay, so that destroys the object. And after we do, let's just spawn the slices object. So for now, just keep things simple. Let's make a direct reference up here. So let's make a serialized field. Let's make it of type kitchen object SO, and for the cut kitchen object SO. Okay, so we have this. Then here in the editor, let's make sure to drag the reference. So let's go inside the cutting counter. Let's open up the prefab, and inside, let's assign this one. That means we need to create the object. So let's actually do that first. So let's create a brand new kitchen object SO. Let's call it for the tomato slices. Then if we do this, we need to create the prefab. So let's once again do the same thing. Tomato slices, make the prefab. Let's go inside this prefab. Let's modify the visual. So use the tomato slices visual. Okay, and drag the reference for the other kitchen object for the tomato slices. Okay, so the visual prefab is good. And let's just go into the kitchen object. Let's just make sure to drag the prefab reference. Then let's assign the tomato slices icon and just call it tomato slices. Okay, so we have the kitchen object SO. Now we can go into the kitchen cutting counter. And over here, let's open up and set this one to the tomato slices. Okay, so we have all the references. Let's go back outside, save it. And back over here in our code. So we have this. Now we just need to spawn this object. So we're really just going to spawn it pretty much exactly like we did over here on the container. So we just go into the script null object, spawn the prefab, and set the parent. So let's do exactly that. Over here, we destroy the object. Then we instantiate the cut kitchen object. And instead of getting into the player, let's put it on this. Okay, so that's it. We should be able to place a tomato directly on top of the cutting counter, and it should be able to transform from a tomato into a tomato slices. Okay, so here we are. Let me pick up a tomato, go up there, drop it, and okay, that works. Now if I press the Alt Interact key, press it, and yep, there you go, it did work. The tomato was destroyed, and the tomato slices were spawned, and now I can pick them up, place them anywhere, and yep, everything works. Alright, awesome. So with this, the basics are fully working. Let's just briefly clean up this code. We already saw a little bit of code duplication. So the cutting counter is going to spawn an object, and the container counter is also spawning an object. So we're copy pasting these two lines of code in multiple places. So instead of doing that, let's put it in just one place. And actually a good place to put this is on the kitchen object class itself. So it makes sense that this one is responsible for spawning more objects. So let's put it over here. However, let us not make it a regular function. Instead, let us make it a static function. Again, just like we saw for the singletons, by making it static, it means that the function is going to belong to the class itself as opposed to any instance. So let's go all the way down to the bottom of the file. Personally, I like to put statics at the end. And over here, let's make public, make it static. We're going to return a kitchen object, and let's call it just spawn kitchen object. And for our parameters, let's receive the kitchen object SO, and let's also receive the kitchen object parent. Okay, so that's it, and we're going to do the exact same thing. So let's go into the cutting counter and copy the code that we were using, and over here, just paste it in there. So we go inside here, spawn the prefab, and set it on this parent. And finally, let's return it. So let's return the kitchen object. Over here, let's pick it up. So the kitchen object, we get it. And then we do kitchen object set the parent. And finally, we return the kitchen object. All right, so that's it. Here we have a super simple function that we can call very easily. It will automatically spawn an object and set the parent. So now let's just call this from somewhere. So over here on the cutting counter, instead of doing all this, let's just go into the kitchen object. Again, remember, let's go through the class name itself and not any instance. And over here, let's call the function, pass in the cut kitchen object SO, and for the parent, it's going to be this. All right, so that is now much, much simpler. And let's do the same thing over here on the container counter. So if the player is not carrying anything, let's give the player this object and give it to the player, just like this. As usual, when we do some kind of refactoring, let's do a quick test to make sure everything still works exactly the same. Okay, so here we are, and if I go to the counter and pick it up, yep, it does work, does spawn the object. Now I can drop it in there, I can cut it, and yep, there you go, everything does work. All right, so far so good. So with all of this, basically we have created a brand new counter where we can cut objects. However, right now there's obviously one huge glaring flaw. If I now pick up a cabbage and I drop it on the cutting counter and I interact with it, that cabbage has suddenly magically turned into tomato slices. Now that is obviously not intended. So for that, let's define a proper cutting recipe, and let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create another scriptable object type. This one is going to be for handling our cutting recipes. So here's our game. I can pick up a tomato, drop it on the cutting counter, cut it, and there you go, slice tomatoes. However, if I could pick up a cabbage, go there, cut it, and there you go, cabbage turns into tomatoes. So we have an obvious issue. The cutting object is currently hard-coded instead of being based on the object we put on top of it. So to solve that, let's make another scriptable object type. Like I mentioned, scriptable objects are excellent for storing and organizing data, so it's perfect for this use case. Basically, we want a scriptable object to hold a reference to the regular object and the cut object, so we can then identify the input in order to spawn the output. Okay, so let's build that. Let's create a brand new C# script. Call it the cutting recipe SO, and let's open it. Okay, so now here let's do exactly that, so something extremely simple. So instead of mono behavior, this one is a scriptable object. Let's add the create asset menu. And finally for the fields, let's do just an input and output. So we've got of type kitchen object SO. Let's go for the input and another one for the output. Okay, so that's really it, super simple. Now here in the editor, before we create it, let's keep things organized. So let's make another folder. Let's make it for the cutting recipe SO. And inside, let's right click, create a new cutting recipe. Let's call it tomato to tomato slices. And over here, let's select the reference. So the input is going to be our tomato and the output, the tomato slices. Okay, so this is how we're going to handle things. So let's go ahead and make actually the final kitchen object SOs. So let's make yet another one, a kitchen object SO. Let's make it for the cabbage slices. And then let's have another one for the cheese slices. Okay, so now let's make these. So as usual, let's duplicate tomato, make the cheese slices, and another one for the cabbage slices. Let's go inside of it, and first of all, drag the kitchen object SO. So this one is the cabbage slices. And let's go modify the visual. So instead of this one, the cabbage slices. Okay. So we have this. Let's save the prefab, go outside. Then the other one we made, the cheese slices. So let's swap this out. Let's find the cheese slices and modify the kitchen object SO. Okay. So finally, just assign the references. So on the cheese slices, drag the cheese slices prefab. Let's assign the icon and call it cheese slices. Okay, so finally on the cabbage slices, so these are the cabbage slices. Let's pick up the icon and let's drag the prefab reference. Okay, so far so good. We have created our new icons. And over here, let's just make all of the other cutting recipes. So we've got two more. So one is going to be the cheese block onto cheese slices, and the other one is going to be cabbage onto cabbage slices. So all we need is just to drag drop the scriptable objects. So for this one, cabbage, let's drop the cabbage on the input, cabbage slices on the output. For the cheese block, that's the cheese block on the input and the cheese slices on the output. Okay, great. All of our data is now stored in some really nice scriptable objects. So now let's go here into our cutting counter. Instead of having a hard-coded kitchen object, let's receive a field of type cutting recipe SO, except we're going to have multiple, so let's actually make an array of this. Call it the cutting recipe SO array. Now for the interaction, this is picking up and dropping things, so let's leave that the same for now. And over here on the alternate, basically we need to find out which recipe we should apply to this. So how I identify that is pretty simple. So we've got the kitchen object that is placed on this object, and we've got a list of cutting recipes, which in turn has the input. So we just need to cycle through all the recipes in order to find the one where the input matches. Okay, so let's go down here, make a function to do just that. Let's make it private. We're going to return a kitchen object SO. Let's call it get output for input. So we give it a certain input and returns the one that matches that one. So it takes a kitchen object SO for the input kitchen object SO. And now here, let's cycle. So do a for each cutting recipe SO in the cutting recipe SO array. So let's cycle through all of these and just check if the cutting recipe SO, if this one dot input matches the input that we received. If so, then this is the one we want. So let's return the cutting recipe SO dot output. And to make sure that the function works, down here, let's return null. Okay, so that's it. We give it an input and we get back the output. So now up here, we just need to make sure to do it before we destroy the current kitchen object. So let's store a kitchen object SO for the output kitchen object SO. And we just get the output from the input. And for the input, pass in the get kitchen object. So that's the one inside of this cutting counter. And let's get the kitchen object SO. So that gives us the output. And then we just spawn that output. Okay, so that's it. Let's test. Finally, back in the scene, let's just go inside the prefab. And over here on cutting counter, we need to make sure to add all of the recipes. So let's add, so the cabbage, then a second one for the cheese block, and finally for the tomato. Okay, so there are all of our recipes. Let's go outside, save the changes, and let's test. Okay, so over here, let's pick up a tomato, go up there, slice it. There you go, got some tomato slices. Now pick up some cheese, go here, slice it, and there you go, got some cheese slices. And finally the cabbage, go up there, slice it, and there you go, some cabbage slices. All right, awesome. So everything is working perfectly. However, now let's say that I want to pick up some bread, and bread should not really be able to be cut. So if I go ahead and I cut it, and there you go, there's our error. We have no recipe that takes bread as an input, so that obviously leads to a null reference exception. Now here we have two options for solving this problem. One option is simply over here when we do the interact alternate. We get the output for the input, and if this one returns null, then we just don't cut it. So we don't destroy it and we don't spawn it. Or alternatively, we can actually add some validation over here when dropping objects. So we can make sure that we only drop valid cuttable objects. Now both approaches are valid, and actually we do need to implement both of them. We'll see why in a bit. So let's do both, starting off with the validating the drop. So first we check if there's no kitchen object on this cutting counter, then we check if the player is carrying something, and then we drop it from the player on this. So over here, let's just check if there's any recipe that has whatever the player has as an input. So let's go down here, make a function to do that, private, let's return a bool, and call it has recipe with input. And we're going to receive a kitchen object SO for the input kitchen object SO. And over here, let's do pretty much literally the same logic. So we have this, and if we find a match, then let's return true. So there's a recipe with that input, if not, return false. So now up here, when the player is carrying something, let's check if has recipe with input, and give it the player, get the kitchen object the player is holding, and get the kitchen object SO. So if there's any recipe that takes whatever the player is carrying as an input, if so, then we drop it. Okay, so like this, let's test and see if we can drop the bread. Okay, so let's pick up some bread, go ahead, drop it, and nope, does not work. Pick up some cheese, and yep, that one does work. However, now we actually also need the other validation that I mentioned. The reason is because if we place a valid object, like for example the cheese there, so that works, and I can cut it, and yep, that does work. However, now the recipe, the cheese block, became cheese slices, and now cheese slice is no longer an input to any cutting recipe. So now if I try cutting again, yep, there you go, I've got another null reference exception. So we need to validate putting objects on top of it and also actually cutting them. That logic is also pretty simple, so let's go down to the interact alternate. So we just check if there's a kitchen object on the cutting counter and has recipe input. And let's get this kitchen object, get kitchen object SO, just like this. So we're only going to cut if there is a kitchen object here and it can be cut. Okay, so let's test. So first of all, the other one, let's pick up bread and nope, cannot drop. Okay, great. Now pick up some cheese and I can drop. Now interact, cut, now cut again. And yep, there you go. No more errors. All right, awesome. Okay, so here we have everything working perfectly. I can pick up a cabbage, go up there, cut it into slices. I can slice some cheese and I can even slice some tomatoes. Everything works perfectly. Now, the one thing missing from our design is we don't actually want this action to be instant. We don't want to just press a button, everything slices instantly. Instead, we want to have the player press the button a few times in order to actually cut. So let's do all that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add the mechanic for the player to be able to cut multiple times in order to actually cut an object. Okay, so we have our cutting counter. I can drop a tomato and press a button. There you go, it cuts it straight away. Now we want the exact same logic, but we want it to take a few cuts before the cut object is spawned. So let's start off by going here onto the cutting counter. And basically, let's keep track of some kind of progress. Basically, the way we do that is pretty arbitrary. It's up to you to decide. For example, you could use a normalized float. However, for cutting, since this is going to be a discrete action, let's actually count the numbers with an int. So let's store a private int, just call it cutting progress. Okay, so now let's begin by actually initializing this progress. So when the player drops something on there, let's set this one to 0. And then down here, when we have the interact alternate, we do our logic, and when we do, let's just increase this by 1. And now we need to know if the object has been cut, so we need somewhere to define some kind of maximum. And for that, we can actually do it directly on the recipe SO. So inside the cutting recipe SO, over here we've got the input, we've got the output, and let's also define an int for the cutting progress max. Okay, that's it. And back here in the editor, let's go into the tomato to tomato slices. Let's say this one takes just 3 cuts. Then for the cheese, let's also take 3 cuts. And for the cabbage, let's say it's a bit thicker, so let's say it takes 5 cuts. Okay, so back in the cutting counter here. Down here, we are adding to our cutting progress. So then we just need the recipe SO in order to grab the maximum. So let's actually go down here and actually make a different function. So this one just returns a boolean. This one a kitchen object SO. Let's make another one. This one is going to return a cutting recipe SO. So get the cutting recipe SO with input. And we're going to receive, as usual, the kitchen object SO for the input. And really going to do the exact same thing that we did up here. Except instead of returning the output, let's return the recipe itself. Okay, so now that we have this more logical one, we can actually get rid of all of this copy-paste code. So over here, we just get the cutting recipe SO, and we just get it and pass in the input. So we have this one over here. If this one is not null, then we're going to return this one .output. And if not, we're just going to return null. Okay, so we're doing the exact same logic, just a bit simpler. Okay, and up here, pretty much the same thing. So has recipe with input. Let's get the cutting recipe SO. And basically just return if this one is not null. Okay, so we have our three nice helper functions. So let's just use this one to get the cutting recipe SO. So let's actually copy this and go up here. So we do the cutting progress. Then let's pick it up, the one for this input. So the input is going to be this one, the object currently on the cutting counter. And over here, we already know that there's going to be a recipe with this input since we've gone through this if. So then we can just check if the cutting progress is bigger or equal to the cutting recipe SO, and let's grab the maximum. If so, then yep, we do spawn it. Okay, so that's it, some very simple logic. Let's test. So here we are, let's pick up a tomato, go up there, and okay, now I'm going to press the Alt to interact. Okay, press once, and yep, okay, so far so good, nothing. Now 2 times. And now if I press a 3rd time, boom, and yep, there you go, got the nice slices. Now for cheese, same thing, 1, 2, 3, yep, it works. And finally for the cabbage, this one should be 5. So 1, 2, 3, 4, and 5. And yep, there you go, everything does work perfectly. All right, awesome. So with this, we now have progress in our cutting logic. Although of course, just like this, it's not very good for the player. The player has no way of knowing what exactly is going on, so we need some kind of visual feedback. So for that, let's add a really nice visual progress bar. And for doing this, we're also going to learn about a really awesome Unity feature. These are world canvases. So before we make the world canvas on the cutting counter, let's actually set something up over here on the scene itself. Let's first create a regular canvas. We're only going to use this in a couple of lectures, but let's first do that one just for now. So let's go on the plus button, go into UI, and let's create a brand new canvas. Okay, so there you go. That creates a canvas and an event system. Now, like I said, we're only going to worry about this in a little bit, but for now, let's just leave those as is. And also, since we're here creating some objects, let's also take some time to organize our hierarchy. Unity sadly doesn't really have any folder objects, so you can't organize the hierarchy in any folders. However, you can use empty game objects essentially as folders. So let's make a brand new empty game object. Let's call it counters. And now, very importantly, for empty folder objects, make sure you put them on 000 so nothing breaks. So make sure you put it on there before you drag the counters. And now let's just drag all the counters inside. So all the clear counters, put them all inside. This one, also drag it inside. And all of these counters, put them all inside. So there you go, now our hierarchy is quite a bit more clean. Okay, so now let's make the cutting progress. So let's click on the cutting counter. And let's go inside our prefab. So let's go inside of it. Now over here, let's right click on the hierarchy and we're going to create a UI. Let's create another canvas. Now for this one, let's give it a name. Let's name it the progress bar UI. And for this one over here on the inspector for the settings, instead of being screen space overlay, let's make this one a world space canvas. Basically, screen space means that it would occupy the entire screen, whereas world space means that this exists in the world in whatever position it is. So let's make it world space, and over here the fields actually unlock. So let's put the positions all on 0, and for the width and height, let's also put it on 0. So basically the canvas is going to be exactly over here. By the way, the shortcut that I just used was the F in order to focus on the object. So this is useful if you're zoomed out or zoomed in way too much, okay? So we have this and we want the bar to be a little bit above, so let's actually lift it up on the Y by a little bit. So over here, let's put it on a Y of 2.5, okay. Now, like I said, the goal with this is to make a progress bar. So inside the progress bar UI, let's create a new UI image. Let's name this one our bar. Let's put it with a width of 1 and a height maybe of 0.2. So there you go, just a really thin bar. And for the color, you can play around, tint it with any color you want. Now for progress, I think maybe a blue or a yellow, something like that makes sense. So let's go with the yellow, kind of like this. Okay, so there's our really nice progress bar. And for this, let's actually use one really nice trick for making a super easy progress bar. The image component has a really easy way of making a slider image. However, it only actually works if you assign an image over here. So let's assign one in order to be able to see those options. And for that, in the included project files, there's a texture white 1x1. This is literally just a 1x1 white pixel. So here it is, just a 1x1 image, fully white. And as soon as we assign it, we do see over here the image type. So we see a bunch more options. And the one that we want is to set the sprite as filled. This one lets you do some really cool, really easy effects. For example, you can make it radial, and look at what happens in there as I modify over here on the fill amount. So as I go down, look at that, it's radially filling. So for some kind of circular progress bar, this would be excellent. But in our case, what we really want is just a horizontal bar. So over here for the fill method, instead of radial, let's go with horizontal. And yep, there you go. Now by playing around this, we have a really nice progress bar. Then if you want, you can modify left to right, right to left, but yep, like this, it looks great. Now in order to modify this visual, really all we're going to need is modify over here the fill amount. This one is a normalized value, so between 0 and 1. So 0 is completely empty, 1 is completely full. However, one issue with this is when the bar is empty, then we can pretty much not see, so we can't see the actual size of the bar. We can see what size it should be. So with this, it's pretty difficult to see how far along we are. But solving that is pretty simple. We can really just add some kind of background. So let's duplicate the bar. Let's name this one the background. For this one, for the image type, we don't want anything, so let's leave it on simple. And for the color, let's put it on kind of a dark gray. Okay, great. And now here's one very, very important thing, is over here on the hierarchy, let's click and drag and place it above the bar. The reason why that is super important is because the sorting order and how it works in Unity. Basically, when it comes to UI elements inside a canvas, the sorting order is based on the order in the hierarchy. Basically, it renders from top to bottom. So the bar on top, the background, this is going to render first, and then the one below it, the bar, is going to render afterwards, which means it's going to render on top. So for the background, we want it to be behind, so place it above on the hierarchy, and that way it renders the background and then renders the bar. Also, by the way, for 2D sprites, Unity has another different sorting method. It's all based on sorting layers and sorting orders. I have a video on that topic if you're interested in 2D games. Okay, so with this, we have the background, and then we have our fill bar. This way we can see if the progress is being filmed or not. Also, one more tiny thing that I like to add is Unity has some really nice, really easy to add effects. So you can go into Add Component, and let's search for a shadow. This one does exactly what you expect. It adds a nice drop shadow. Over here on the effect distance, let's put it on 0.1, 0.1 in order to see. And actually, let's not do it on this one, but do it on the background. So let's get rid of this. Instead of going to the background, over here, let's add the same shadow. So if you put it on 0.1 and minus 0.1, yep, there you go, a nice simple drop shadow. Or the other one that I prefer, so instead of the shadow, let's add a really nice outline. Once again, for the effect distance, 0.1, 0.1, or maybe actually 0.05, just to be just a tiny bit. And let's raise it on the alpha, so there you go, nice little outline to our bar. This is just a visual thing, so you don't have to add this, but personally I find that it looks pretty good. So with all of this, we have our visual perfectly set up. We've got our nice bar. All we need to do is play around the fill amount in order to fill it. So now all we need to do is to connect this to the logic. But as usual, let's make sure to write some good clean code. So we do not want the cutting counter to directly touch on this image. Instead, let's make a script to handle that. So let's right click, create a new C# script, call it the progress bar UI. And just personally as a rule, I like to append the UI to any UI script. You don't have to do that, it's just a rule that I personally find helpful to follow. That way, just by looking at the scripts, I can immediately see this one is a UI, this one is script and logic, and so on. So on the progress bar UI, on the main game object, let's attach the script and let's open it. Okay, so now here we're going to need a reference to our image. So let's add a serialized field, private, and we're going to need the image type. And importantly, this is inside using Unity Engine.ui. So let's go up here using Unity Engine.ui. So we have our image component. Okay, great. Let's call it the bar image. So we have our reference. And now with this, obviously, we need to have some kind of reference to the counter so we know when the progress changes. So it's really the same thing that we've already done so many times throughout this course. So let's add a field up here, serialized field, private, cutting counter for our cutting counter. Then over here in the editor, let's drag the references. So drag the reference to the cutting counter and another one to the bar image. Okay, great. Now we just need some kind of event to update the bar image. So let's go over here into our cutting counter script. Let's make an event to spawn that. So public event, let's use the event handler, the default standard. Let's call it on progress changed. And let's also make a nice event args to be able to send the current progress amount. So let's make a public class on progress changed event args, and let's extend event args. And then inside it, let's put the current progress. However, let's also pass in the progress as normalized, since that's what the bar will use. So public float progress normalized, and we're going to make this event of this type. Okay, great. So we have our event. Now, whenever we modify the progress, we just need to fire this event. So over here, when resetting the progress, let's fire it. So let's invoke, pass in this, instantiate our event args, and pass in the progress normalized. And to get the normalized progress, it's actually very simple. Basically, we just need to divide the current progress by the maximum. So cutting progress divided by cutting progress max, which is actually inside the recipe SO. So we need to pick that one up. So let's go down there to pick up the cutting progress recipe. So we pick this one up and we go in there and get the maximum. However, over here, we also need to be very careful because there's one sneaky issue here. This has to do with how C# works and how ints are divided with other ints. For example, if we had a cutting progress of 1 and cutting progress max of 5, you would think 1 divided by 5 would equal 0.2. However, if we actually did that, over here we would actually get a 0. And the reason for that is because we are dividing two ints. Cutting progress is an int, cutting progress max is also an int. And if you divide an int by an int, then the end result will also be an int. Since you cannot define 0.2 in an int, the decimal gets cut down and you end up with just 0. So that would not be correct. In order to get the right value from this calculation, we need to make sure to convert one of these values onto a float. So that's really simple, we just cast one of them, so just cast this one to the float, just like that. Basically, now this one will first be cast to a float, and then we're going to have a float divided by an int, and the end result will be a float. So if you ever do some math and you get some weird results, always make sure to check the type of your numbers. Okay, so here we are correctly firing the event, and then down here when adding our progress, let's do the same thing. Let's also fire on the event. So now we can go back into our progress bar UI, and over here let's listen to the event. And again, remember that if we're accessing an external reference, let's do that on start and not on awake. So cutting counter, listen to the on progress changed event. When that happens, let's just go bar image and set the fill amount to what we receive from the event, so the progress normalized. Okay, so that's really it. And also up here on start, let's initialize it as 0f, so the bar is nice and empty. Okay, so let's test. Back in the editor, let's just go back into the scenes, make sure the prefab has been saved, and let's hit on play. And right away, yep, we do see the bar. Yep, it is empty. Now pick up some cheese, drop it, and if I cut, and yep, there you go, added a little bit of progress, now a bit more, and there you go, there's our cheese. Okay, great, everything does work. Now let's add just one more tiny bonus thing. We can add some extra logic in order to hide this visual if the bar is either completely empty or completely full. That is actually pretty simple. Over here on the progress bar UI script, let's just make some basic show and hide functions. So private void show, and then we're going to have a private void hide. On these ones, just game object set active, this one set it to true, and this one set it to false. Now on start, we subscribe to the event and then let's hide it, okay. Also here, it's very important, make sure you hide it after you listen to the event. If, for example, you called hide on awake, that would disable the game object and the start would never run, so it would never listen to the event. So if you ever set the game object as inactive, make sure you do it only after you're listening to whatever events you want. So we have this, that's great, and then when the progress changes, let's just do a basic test. So if e.progress normalized equals 0f, or if the progress normalized equals 1f, so if the bar is completely empty or completely full. If so, then let's hide it. And if not, then let's show it. Okay, that's it, let's test. Okay, and yep, by default starts off hidden. Let's pick up a tomato, go up there, and yep, still hidden. Now I cut, and there you go, there it is, cut again, and yep, there you go, it hides itself. Okay, great, so we've got a nice little visual. Let's do just one more final thing. Let's add a really nice animation. If we go inside the cutting counter, and we'll look at the cutting counter visual, over here, note how it already has an animator. Just like we did for the container counter, it's all very simple. So basically just has a cut parameter. When that happens, it just cuts the counter. So it just plays a simple animation. Since it's going to be pretty much exactly like the container counter, let's actually duplicate that script. So let's go down, find that script. So the container counter visual, let's duplicate this. So Control D. Let's rename this to the cutting counter visual. Okay, let's open. And over here, let's rename the script. So the cutting counter visual. Okay, great. Then for the parameter, let's rename this. Instead of open close, it's going to be called cut. And for the string, it's cut. Again, make sure you write it case sensitive. Make sure it's all correct. Then instead of having a container counter, we've got a cutting counter and a cutting counter. And finally, we just need to listen to the correct event. So technically, we could listen to the onProgress changed. However, that one also gets fired over here when the cutting progress is 0. We don't want the cut animation to play when this happens. So let's just make another simple event. So a public event handler. Let's call this just onCut. Okay, and then down here when we have our cutting progress, so we cut and let's just invoke this event. Okay, that's it, super simple. So now on the cutting counter visual, let's go into the cutting counter and into the onCut event. Let's listen to this. And we're going to set the trigger exactly like this. So get rid of the container counter like this. Okay, there you go, a very simple script. So now here back in the scene view, inside the container counter prefab, let's just go inside the visual. Let's attach the cutting counter visual. Just need to drag the cutting counter reference and that's it. Let's exit the prefab, save it, and let's play. Okay, so now let's pick up a cabbage, go up there, drop it, and on to interact. And if there you go, we've got a nice little animation. All right, awesome. So I can drop things, I can cut them, and everything works perfectly. All right. So here we added a cutting progress to our cutting counter, and we also learned about yet another very useful Unity feature called world canvases. And at the same time, you might have also noticed that the canvas is looking at the camera in kind of a weird way, basically just pointing straight forward. This can sometimes make it difficult to see, so let's work on that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to build a very simple but very useful script to make an object look straight at the camera with various options. Okay, so we previously made the cutting counter, and when I place something, yep, there's a nice progress bar. So now that this is working, let's do one more thing. Right now, look at how the bar is oriented. It's looking quite a bit slanted. That's because we have a perspective camera and it's looking from top down. Now, this is one of those things that is kind of personal preference, so maybe you don't like it just like this. But a lot of the times you want these World UI elements to face the camera just like a regular UI. One example of this problem is, for example, let me pick up the cutting counter, duplicate it, and let's put one down here. So rotate it upwards. Okay, let's put it on 4.5, 0, and -5. Now if I place something on there and I cut it, yep, look at that, the bar is now inverted. So let's make a simple script to solve this problem. Let's go into our scripts, create a new C# script, call it look at camera. Let's go onto the cutting counter prefab, let's open it up, go inside, on the progress bar, let's attach this script, so the look at camera. Okay, now let's open. So from here, let's use an interesting function. So let's use a private void late update. So not update, we have the late update. So if this is the first time you're hearing about this, like the name implies, this one is going to run after the regular update. So every single update and all the objects is going to run, and then all the late updates. So kind of like you've got awake and start, you have update and late update. Why this is useful specifically for this script is because for this element you really want this to run, the orienting logic, you want that to be done after whatever that object does in the update. In this case, this object will never move, so it's not really an issue. But for example, if you had some kind of moving vehicle with a world canvas on top, if you had that, you would want to set the world canvas location to look at the camera after the vehicle had moved. Otherwise, the canvas would not look perfect. So anyways, because of that, here we're doing on late update. And now we can just look straight at the camera. So we can just do transform.lookAt. And for the target, pass in the camera.main.transform. This function makes this transform look at another transform or another point, so this will make it look straight at the camera. Also, by the way, one quick note here. In some older tutorials, you might see people telling you not to use camera.main. The reason for that is because this field did not used to be cached, so every time you use this, it would cycle through every single game object in the scene until it found the main camera, so that was obviously really bad for performance. But nowadays, this field is now cached by default on the Unity backend, so you no longer need to cache it yourself. Accessing it directly just like this is now fine. Okay, so with this, let's test. Just make sure to save the prefab and let's hit on play. Let's go ahead, pick up a cabbage, put it up there, and yep, there you go. Look at that, how it's looking straight at the camera. And for this one down here, same thing, cut it, and yep, there you go. Both of them are looking straight at the camera. Okay, so that's great. You can also see exactly what it's doing if we try to move the camera. Again, we're using Cinemachine, so let's move the virtual camera. So over here, if I just play around with the position.x, look at that, look how as I move the camera, yep, the objects are perfectly looking straight at the camera. So that's great, that's what we want. But also you might notice one thing, notice how the bars are actually inverted. Instead of going left to right, they're actually going right to left. Basically this has to do with how the canvas by default assumes you are essentially going to look at it from behind instead of looking forward. So that is why when this game object is pointing straight at the camera, it's essentially inverted. So to solve this, actually quite simple, we basically just need to look in the exact opposite direction. But at the same time, sometimes we might want this exact behavior, having something look straight at the camera. Maybe we do want it to be inverted sometimes. So for that, let's make a nice complete script with all of our possible options. And for defining options, this is also an excellent way to learn about one more thing, which are C# enums. Enums are an enumeration, meaning a fixed set of options that you can have of something. So these are really useful when you have a fixed set of something, like for example, maybe a fixed number of options. So for example up here, let's make it private, make it an enum, and let's call it mode, and then inside we can define all of our options. So let's say we have the regular look at, and then look at inverted. Okay, so we have these two options in our enum. Now let's do a field of this type and expose it in the editor. So let's make a serialized field, private of type mode, and call it mode. Okay, let's save this and look what this looks like in the editor. And if we go inside the cutting counter and we look at the progress bar, you can look at that, the mode shows up and it shows up as a really nice drop-down menu. So since we have a limited number of options, we've got a really nice menu where we can choose each one you want. So that's really awesome. That's one of the benefits of enums. They are really easy to use over here in the editor. Now back in the code here, let's decide which one to use. So on the late update, let's just do a switch on our mode. In case we are on the regular look at mode, then let's do exactly this. Let's simply look at it. In case we are on the look at inverted, for this we just want to look at the inverse position. So that's actually pretty easy. We just calculate the direction vector from the camera to this object. So a vector 3, call it dir from camera. And to get direction from the camera, we start from this object, so this transform.position, subtract the camera.main transform position. So this gives us the direction pointing from the camera. And then we just do transform.lookAt. And instead of looking at the camera, let's look at the opposite position. So let's look at transform.position, so our current position, plus the direction from the camera. So we're going to be looking at the exact opposite point. Okay, so that's it. Let's test. And right now by default we have the regular look at. So let's just see it. Let's just place some objects. Okay, so right now it's still inverted. And something really nice is you can play around the enums even as the game is running. So let's go inside the cutting counter on the progress bar UI. For this one, let's swap from look at to look at inverted. And yep, look at that. That one is now looking perfectly. So this one is using look at and this one using look at inverted. Okay, great. It's all working. However, yet another thing that is all about personal preference. Note how the visual has a slight slant. This is due to how the visual is actually looking directly at the center of the camera. So you can really see it if I move the camera left and right, how it slants going left or going right. Again, this is all personal preference, it's just a visual, so maybe you do want this look. But let's see another method. So over here in our modes, let's add two more. Let's add camera forward and camera forward inverted. And then down here on our late update, let's add those. So the camera forward, and then we have the camera forward inverted. So for this one, for the camera forward, it's super simple. Let's just take this transform, use the forward, which again you can get or you can set it, and let's set it to the exact same one as the camera.main.transform.forward. And for the inverted, exactly the same thing, except instead of forward, we do minus forward. Okay, so let's see what this looks like. Okay, so here's the game with both counters. They're both currently using the look at mode. Now if I put it look at inverted, yep, that one goes left to right. Okay, great. Now if I put camera forward, yep, look at that. Now that one is perfectly straight. So even as I move the virtual camera left and right, look how that one is always perfectly facing the camera as if it was a regular UI element. And for the inverted, does the exact same thing, but inverted, so just like that. So that's it, these are the 4 modes. Again, these are all just visual elements, so pick whatever you prefer. For me, I'm going to be using this one, the camera dot forward, so that everything is perfectly horizontal. So I'm just going to make sure to go inside the prefab, and on the prefab itself, modify it and set it as camera dot forward. And now if I add the cheese there, yep, looks great. And if I add a cabbage here, and yep, it also looks great. Alright, so here we created a really nice, useful, generic script to make an object look straight at the camera in various ways. Note how this one has nothing to do with canvas or a progress bar or anything. It's really a generic script to look at the camera, so you can apply this to anything where you want it to look at the camera. Okay, so with that, the cutting counter is fully done. Now let's handle the trash counter in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, let's create the trash counter. This one is actually pretty simple. It's how we're going to drop something and just destroy it. Okay, so making the trash counter is going to be super easy. Once again, going to be another great practical example of the power of writing good clean code and having good organization in your project. So let's do the same thing that we've already done a bunch of times. So first of all, let's make the prefab variant. So let's right click on the base counter and create a brand new prefab variant. Call it the trash counter. Okay, let's go inside. And first of all, let's drag the visual. So find the visual prefab on the trash counter. Okay, then let's duplicate it to make the selected. So let's rename this to selected. Let's add the selected counter visual. Let's add the visual inside of it. And on the visual, let's select the other material. So the counter selected. And finally on the selected, put it 1% bigger, 1.01. And start off with the visual disabled. Okay. So that's the basics, just like we've already done so many times. Now let's make the script to run this. So let's right click, create a new C# script, call it the trash counter. And by the way, here we're already starting to have quite a bunch of scripts, so we should probably organize this scripts folder. So let's make a new folder. Let's call it counters. And let's make another one and call it scriptable objects. So on the counters, let's drag the base counter, clear counter, the container visual, the cutting visual. Then down here, the trash counter. Okay, let's drag them all onto the counters folder. And on the scriptable objects, let's put the cutting recipe and the kitchen object SO. Okay, now our folder is a bit more organized. So let's open up the trash counter. And over here, as usual, let's begin by extending the base counter. Okay, great. Then let's implement the regular interaction. So override the interact. And on this one, again, it's going to be super simple. We just check if the player is holding something, and if so, we destroy it. So just check if player.hasKitchen object. So if the player is holding something, go into the player, get the kitchen object the player is holding, and simply call destroy self. And that's it, it's this simple. Back in the editor, let's just attach a script. Let's make sure to drag the countertop point reference, and on the selected, drag the base counter reference. Okay, with this it should be working, so let's exit the scene, let's save the prefab, and let's drag it over here onto our scene. So let's drag the trash counter and put it maybe somewhere over here on the corner. So let's put it here on an x of 7, y 0, and -3.5. Then let's also fill up these spots down here. So let's duplicate the clear counter, put one in there, put another one in there. Let's put another one on the side, and for the trash counter, let's align it. So let's put it a bit more to the side, so on 7.5. Okay, great, and let's put it inside the counters, and now we can test. Okay, so let's see if we can interact with it, and yep, as I approach, yep, I do see it highlighted. Okay, great, and if I interact, obviously nothing happens since the player isn't holding anything. Now if I pick something up, let's say a tomato, and I don't want this tomato, so I want to trash it, and yep, there you go, it does get trashed. Alright, awesome, so this is literally it. Like I said, this is once again another excellent example of the power of writing good, clean code. This was super simple to implement because we have a really nice structure for how all of our counters work. Also because our interaction system is very well built. Also because the kitchen object system is very well made. It's because of all of that great, very clean code that we were able to implement a brand new counter in literally about 60 seconds. So once again, I hope that by following this course, you now understand why I'm always talking about the importance of writing good, clean code. It's exactly because of this. If you write your code correctly, it makes developing the game so much easier. At first, it might seem like the quick and dirty approach is faster, and usually in the beginning it is faster, but as soon as you add some complexity, the quick and dirty approach suddenly won't scale. Whereas the well-built, clean code approach, this one will continue scaling very well. So here we have a fully functional trash bin so we can dispose of unwanted objects. Next, let's build a much more complex counter. Let's build a stove counter, which also requires building a really nice state machine. So let's do that in the next lecture. Hey again, another quick intermission. You're past the halfway point, so congrats again. By now, I really hope you've already learned a ton from the course. We've already covered lots of topics and built a ton of systems. I hope you've been following the website as you go through the lectures, and I hope reading the frequently asked questions has helped you in some way. Let me know in the comments how you've used the course website. Did you just read the FAQ, or did you also download some project files? Let me know, I'm curious to know. If you enjoy my teaching style, also look at my other courses after finishing this one, especially the turn-based strategy course. That one is an excellent follow-up for this one. Okay, there's still quite a bit more for us to build and learn, so let's continue in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build the stove counter. So we want to place some uncooked meat, then we wait for a bit for it to be cooked. However, if we wait too much, it's going to get burned. So let's implement that. Alright, so as usual, let's first begin by making our counter. So let's go inside the prefabs, the counters, let's right click on the base counter and create a new prefab variant. Call this the stove counter. And as usual, let's go inside of it. Let's find the visual. So inside the prefab visuals, the counters visuals, here is the stove counter, so let's drag it. Then let's duplicate this, rename this one the selected. Let's add the component, the selected counter visual. Then let's go inside on all of these. And by the way, this visual actually has some nice visuals that we're going to implement in a little bit, but for the selected, we really just want the static objects. So let's pick up all of these and let's select the counter select visual, okay, nice and white. Then let's lock over here the parents so I can select all of these and drag all of them. Okay, great. And start off with all of them disabled. Okay, so that's the basic setup as usual. Just for the counterpoint, since this one has a nice little sub on top, let's lift it up by a little bit. So put it on a Y of 1.456. Okay, that looks pretty good. Just move it a little bit to the center. Okay, great. So now let's make our script. So let's go inside our scripts folder. We've got our counters. So in here, let's create a brand new C# script for the stove counter. Let's wait for it to compile. Let's attach the script and open. Okay, so here as usual, let's extend the base counter. Now, like I said, the goal for this one is to be able to cook our meat. And for that, it's going to be based on a timer. And to actually cook the meat, we're going to need to know which one is the uncooked meat type and which one is the cooked meat type. So for that, we really want the exact same logic that we did for the cutting action. We want some kind of place where we can store an input and output as well as a cook timer. So for that, let's actually just duplicate. So let's go inside our scriptable objects for the cutting recipe and let's duplicate this one. So Control D. And let's name this one the frying recipe SO. Okay, let's go inside. And over here, let's rename the object. Then we have an input, we have an output. And then instead of progress, let's have the frying timer max. And since this one is a timer instead of an int, let's make it a float. Okay, so that's it, pretty simple. Then back here in the editor, let's create our scriptable object. So let's go inside, let's make a nice folder. So a folder for the frying recipe SO. And inside, let's create one. So let's create a brand new frying recipe SO. For this one, let's call it meat patty uncooked into meat patty cooked. Then for the inputs, let's choose the meat patty uncooked. Now we have to make the other one. So let's go ahead and make that one. Let's duplicate this one, rename it to the meat patty cooked. And the object name, meat patty cooked. Let's select the different sprite. So this one is going to be the meat patty cooked, okay? And finally for the prefab, let's also make it. So for the meat patty cooked, let's go inside of it and also make sure to save the changes on our stove counter. So okay, now in here, let's get rid of this visual and use the other visual. So we want the meat patty cooked, and let's make sure to drag the scriptable object. Okay, so it's all good here. Let's go back outside, save it, and finally over here on the meat patty cooked, let's just grab the prefab reference. So there you go, that one. Okay, so this one is working, and since we're here, let's actually make the other one right away. So let's make the meat patty burned. So the prefab, and let's also duplicate this to make the meat patty burned. Then on the text, let's rename this to burned. Let's choose the burned icon. And for the prefab, let's go into our meat patty burned and swap it out for the burned one. So there you go, nice and charred. And over here, swap it for the meat patty burned. Okay, let's save it. And finally down here, just make sure everything is correct. So in meat patty burn, just drag the scriptable object, the transform prefab, just like that. Okay, so all of our burned references, over here all of our cooked, and over here all of our uncooked. And again, when going through this process, always make sure that you match all the references on the scriptable objects, and also over here on the kitchen objects. So meat patty burn, yep, meat patty burn for the uncooked, and for the cooked, there it is. Okay, everything is good, great. So now we can go back over here into our frying recipe SO, and for the output, let's output the meat patty cooked, and for the frying timer, let's put it on 3 seconds. Okay, so that's it, great. Now back in the code here on the stove counter, let's add an array of our frying recipes. So a serialized field, private, it's going to be an array of frying recipe SO, so frying recipe SO array, and call it frying recipe SO array. Okay, great. Then back here in the editor, let's go inside the stove counter. Let's make sure to drag that. So let's drag the meat patty from uncooked into cooked. Okay, let's also drag the counter top point. And finally, since we already made the script over here on the selected, we can also drag the selected. Okay, so our stove prefab should be working. Okay, let's go outside, make sure to save the prefab. Okay, now let's continue with the rest of the script. So let's make our override. So override the interact action. And when we interact with it, let's validate dropping the object just like we did on the cutting counter. So let's go over here into our cutting counter script and let's just copy pretty much the exact same thing. So let's copy all of this interact code. Let's go over here in the stove counter and just paste it. Now we also need to copy in our recipe. So over here on the cutting counter, let's copy paste those functions. So these functions go into the stove counter and over here, let's paste them. They're going to work pretty much the same thing. So we get an input, except instead of being a cutting recipe SO, we're going to have a frying recipe SO. So let's replace all the cutting recipe references with frying recipe reference. Then for the array, this one is the frying recipe SO array, and obviously let's rename these. So Control RR to rename all of them into frying recipe SO. Let's also rename the function. Instead of get cutting recipe SO, it's the frying recipe SO. Okay, so there's no more mentions of cutting over here. So let's use this function up here and up here. And just make sure to rename these the frying recipe SO. And down here, also same thing. So the frying recipe SO. Okay, so down here we have no more mentions of any cutting. Let's just go up here and solve all of these problems. So first we check if there's no kitchen object here, and if the player is carrying something, then we see if what the player is carrying matches any kind of frying recipe. If so, then the player is carrying something that can be fried. Then we set the parent, and for now let's not worry about the progress. So let's just get rid of all of this, just like this. Okay, so with this we should be able to drop, but only an uncooked meat. So back in the editor, let's just set up our scene. So let's drag a stove counter onto our scene. Let's put over there on X of 6, Y of 0, and 3.5. Alright, so let's test. Okay, so now if I pick up some cheese, I go up there and I drop it, and nope, doesn't work. Okay, great. But if I pick up some uncooked meat and I go and I drop it, and yep, that does work. Okay, great. So it works, and I can only drop the actual objects that match the recipe. Now, unlike the cutting counter, this one will not be based on a player-alt interaction. And actually over here, let's fix this minor issue. Basically, we added this debug.log error to the base interact because pretty much every single counter is going to implement this interact function, but not all counters are going to have the interact alternate action. So on this one, let's just do nothing. Let's not spawn an error. Okay, just a quick fix. So like I said, the stove counter, this one is going to be based on a simple timer. And for making some time-based logic, basically we have two approaches. One approach is to use a simple float timer, or you can also use a coroutine. Now, a lot of tutorials will teach you how to use a coroutine, and that's not necessarily a bad practice. It does work. It does achieve the desired result. So to do that, you would just make a function like fry timer. So you'd make a private, you have to return I in numerator, then call it something like handle fry timer. Then inside you can do a yield return and return a new wait 4 seconds. And to start this coroutine, you would do maybe on start, you would call start coroutine and start the handle fry timer. So this is one approach. This is definitely perfectly valid timer code. However, personally, I am not a fan of coroutines. It's not because of performance or anything. It's simply because I don't like the pattern that they force you to use. I don't like being forced to make a function that returns I in numerator. I don't like using yield return. I don't like having to use the start coroutine function. I don't like being forced to use this on a monobehavior object. Those are all requirements for making a coroutine work. And personally, I find those are way too many requirements that create a very strange pattern that I really don't like. So that's really the only reason. I don't like coroutines because I find this pattern to be quite a lot convoluted. So instead of coroutines, what I like to use are simple basic float timers. So just make a simple private void update. Then we just need to keep track of a certain timer. So for example, a simple private float frying timer. Then on the update, let's first check that we have an object, so it has a kitchen object. If we have a kitchen object, then let's increase the timer by time.time. By the way, here when working with a timer, you can increase or decrease. It's pretty arbitrary, both ways work. The obvious difference is only if you test if it's above the max or if it's under 0. In here for frying, it does make sense to start at 0 and then the frying timer max. So you do that, and if the frying timer, if it is bigger than the maximum, so let's get the frying recipe SO, let's get the frying recipe SO with input, so let's get this kitchen object and get the kitchen object SO. Okay, so we go into the frying recipe SO and we get the frying timer max. Okay, so if it's above the max, then this one has been fried. So here let's just see what we did on the cutting counter. So let's get this kitchen object and tell it to destroy itself. And then let's go into the kitchen object class. In order to spawn another kitchen object, let's go into the frying recipe and spawn the output. And we're going to spawn it inside of this counter. Alright, so that's it. This should already be working. We don't have a visual yet, so let's add a debug log. So up here, just a debug.log on the frying timer. And up here, let's also just reset the timer. So frying timer, let's put it on 0f. And let's also do a debug.log and say fried. However, like this, you might already be guessing that we're going to have a bunch of bugs, but still, let's just test it just like this. Okay, so over here I can move around, I can pick up some uncooked meat, I can drop it there, and after a little bit, there you go, there's the timers. And yep, there you go, it did work. You can see the timer increased until 3, then it was fried, then it was reset, and then we've got a null reference exception. Basically, this is the exact same problem that we had on the cutting counter, where first we put an object like tomato, and that is indeed an input for a recipe. So we cut tomato into slices, but then the slices are not an input for any recipe. So over here we put some uncooked meat, so that's great, we fry it, which means we destroy the uncooked meat and we spawn the cooked meat. But then next time the cooked meat is not an input for anything, so obviously this one is going to return null. One thing we can do to sort of solve this problem, which is also going to be beneficial in terms of performance, is simply caching this field. So let's go up here, define a frying recipe SO. Instead of constantly getting it on every single update, which might be a bit costly in terms of performance, instead of this, let's just get it over here when the player drops something. So the player drops something, and we assign the frying recipe SO, so we assign it, cache the value, and then do this. Okay, that should have fixed the null reference problem, but we still have a bunch more problems, but still, let's test it out. Okay, so here, let's pick up some meat, put it there, and let's look at the timer, and yep, there you go, everything is cooking, great, and yep, there you go, it finished, it cooked, and the timer was reset, and now it's finishing, it's cooking, and so on. So this is obviously another pretty serious problem. Basically, it's constantly frying the meat and spawning more and more objects. Instead of constantly spawning from the same recipe, what we want is for the stove to first fry the object, but then if the object is fried, then we want to burn it. So really, that means that we want the stove to have multiple states. Meaning that we're going to need to make a simple state machine. So let's do just that. Now, if you're a beginner, the concept of a state machine might seem daunting at first, but it's actually extremely simple, at least to make a very basic one. All we need is really just a bunch of states. So to define those states, let's go up here and make a simple enum. So let's make a private enum, call it state. And now let's put all the states for our state machine. Now for the stove, let's say we have idle when there's nothing on top. Then let's say we have a frying state for when the ingredient is actually being fried. Then we have fried for when the ingredient has already been cooked, but it's still getting some heat. And finally, if we leave it too long in that state, then everything ends up burned. Okay, so these are all of our states for our state machine. And now to make the actual state machine, it's actually quite simple. First of all, we just need to store the current state. So up here, make a private of type state and store the current state. And then on update, let's just do a switch on the current state. And now here, basically, we're going to do different logic depending on the state that we're at. So let's say if we're idle, we do something. Then if we are frying, we're going to do something else. Then if we are on the fried, also something else. And finally, if we are on burn, do something else. So here are all of our states. And the logic that we did down here, this is the frying logic. So let's actually just copy all of this and let's paste it inside the frying logic. And for the state machine, we're only going to run any of these states if there's a kitchen object inside of it. So let's actually put that switch in there just like this. Okay, so that's it. So when idle, we're not doing anything. And when frying, we're going to run our frying timer. We're going to fry the object. Let's also get rid of the log. We no longer need this. Then we destroy the current object and we spawn a brand new object. Now what we need is to handle over here the state field. We need to modify this when changing states. So first of all, let's handle the start. So let's make a private void start. And on start, let's begin with the state on state.idle. Okay, great. Then down here, when we interact, when the player drops something, that can be fried, over here, let's set the state and put it on state.frying. And over here, we should also probably reset the timer. So let's set the frying timer back into 0F. Okay, we set the timer and we reset the state. Finally, up here, let's not reset the timer since we're resetting the timer down there, since it makes more sense down there. So we do the frying timer, we end up frying, and then obviously we need to modify the state. So modify state and put it on state.fried. Okay, so that's the basics of our state machine. With this, everything should be working just the same as previously, except we're only going to fry once. So let's actually just put a log here, debug.log, object fried. And let's put one down here outside of the state machine. Just do a debug.log on the state. Okay, like this, let's test. Okay, so here we are. Let's pick up some meat and drop it on there. And there you go, it goes from idle directly into frying, and then it's fried. And yep, there you go, now it stays on fried. So it no longer goes on frying and it's no longer spawning any more objects. It went from frying into fried and yep, everything worked. All right, awesome. So we have the frying state working perfectly. Now let's handle the burning. In terms of logic, it's really going to be the exact same thing. We're going to have a frying timer. So let's copy this code and paste it down here. Now, technically we could reuse the exact same float timer, but that would be a bit confusing. So let's keep our code as clear as possible and really just make a different timer with a more descriptive name. So here a private float, call it the burning timer. Then let's initialize this timer. So when we go into the fried state, let's set the burning timer into 0. Then down here, let's use this burning timer. Okay, great. When timer is elapsed and the object is spawned, let's go into the burn state. And now obviously we need another recipe. So let's make another scriptable object. Back in the editor, let's find the frying recipe SO. Let's duplicate this. Call it the burning recipe SO. Then over here, let's modify the name. Instead of frying timer max, let's call it burning timer max. Okay, great. So now over here on the stove, let's use pretty much the exact same thing. And let's make over here private of burning recipe SO, the burning recipe SO. Then down here, we just need a function to get the burning recipe SO. So let's copy this and paste it over here. This one's going to return a burning recipe SO. So let's replace this and this. Rename this into burning recipe SO. We're going to need an array, and over here, let's just change the name. Instead of frying recipe SO, the burning recipe SO. And finally, let's just find a new array. So let's go all the way up here, make another array, an array of burning recipe SO. And this is the burning recipe SO array. And finally, if we go down here, let's use this array. Okay, that's it. So now let's use this function to set our burning recipe SO. So when we set it to fried, let's set the burning recipe SO. And let's get it with the input, and the input is going to be the object that is on here. So the kitchen object dot get the kitchen object SO. Okay, so we're initializing our fried state and setting up the burning recipe SO. And over here we use that one dot max, and we go into that one and use the output. So over there object fried, and over here object burned. All right, so that's pretty much it. We modified everything to say burning timer. Over here we are correctly initializing, so we go through the burning timer, through the burning recipe SO, which we are grabbing up here. Then we spawn the output on the burning recipe SO, and we go into state.burned. Okay, so all that's left is just filling in this array. So back in the editor, over here, let's make the object. So let's make a brand new folder for the burning recipe SO. And now inside, let's create a new burning recipe SO. Call this one the meat patty cooked into meat patty burned. And over here, let's set the input, so the meat patty cooked onto the meat patty burned. And for timer, let's make it take a bit longer to burn, so let's say 5 seconds. Okay, that's great. Let's just drag the reference. So let's go into the stove counter and let's make sure to open up and go inside the prefab. And over here on the prefab, just drag the burning recipe. Okay, that's great. Let's go outside, save the prefab, and let's test. Alright, so here we are. Let's pick up some meat, drop it on there, and look over there. It's frying, and after a bit, yep, it's fried. There you go, it spawned that one. And now if we wait for 5 seconds, it should go from frying into burn. And yep, there you go, that one is charred. Everything is burned, everything is great. Alright, awesome. So everything worked as intended. With this, all of our logic is working. Now let's handle picking up objects from the stove. Now technically it's already working, so I can approach the stove and pick it up the object, and there you go, drop it in there. So that does work. However, if we look over here in the log, the state machine is now in the wrong state. So over here, let's do a quick fix. Let's go down into the interact action. Okay, so here it is. So if there's no kitchen object, then the player places it. Okay, that's good. But if there is a kitchen object, so if there's something on the stove counter, when the player picks it up, let's also manually set the state and put the state back into idle. Just like this. Okay, that's it. So let's test. Okay, so over here, let's pick up some meat, put it in there. It's cooking, and let's wait until it gets finished. Yep, there you go, it's done. Pick it up, and there you go, out. Now, if I want, I can put another one, and yep, there you go. The logic is reset, and everything is back to normal. Okay, great. So all of the logic is working perfectly. Now let's just get rid of our logs, so we don't need this. So let's get rid of that debug log, this one, and this one. Okay, great. Everything is nice and clean. And now let's add some nice fun visuals. So if we go inside the stove counter, and over here is the visual, and I include these two prefabs inside the visual. So one of them, this one, the stove on visual, this one is just a glowing red square. Now again, there's a weird bug on this specific Unity version, so post-processing isn't showing over here on scene view. But if I leave it enabled and I go back outside, and now if I look in the game view, yep, there you go, there's a nice glowing red square. If you don't see it glowing, make sure you add the bloom post-processing effect. So if you missed something, you can go back into the post-processing lecture and make sure everything is set up correctly. So there's a nice glowing red square, and there's also a bunch of particles. So you can enable this one, press on restart, and there you go, just some nice particles just jumping up. This was made with the Unity particle system. So for example, on the hierarchy, you can right-click, go up here into effects, and you can create a particle system. So that's what this is. It has a particle system, and over here you can see all of the various settings. For these particles, they just jump up and fall down. So for jumping up, that is the emission. You can actually see a visual over there of the cone. That is the spawning cone, which you can find over here on the shape. So in the shape, it has the shape of a cone. Then you can see the radius thickness, and so on. So that is from where the objects are being spawned. Then up here, you can see the lifetime of each object. So each particle is going to last for 0.7 seconds. You can also see the speed, so that's the speed at which they come from there. The start size, that's how big they are on start. And note how the particles are spawning, jumping up, and falling down. So that falling down is over here the gravity modifier. If you put it at 0, then they just keep going up. And if you put it at 2, yep, they go up and they fall down. Next down here on the emission, this is how many are being spawned. So if I put this on 200, there you go, tons and tons of particles. Next is over here the size over lifetime. So this one has just a basic curve. So they start off on full size, and over the x-axis, this one is the lifetime. So as the particle goes from the beginning until the end of their life, they basically go down on size, so that is why they become quite a bit smaller. Also, by the way, this one down here, this one is called an animation curve. This is another really useful Unity feature. I have a dedicated video on animation curves. And finally, down here, just have the renderer. So it's just using some basic particles, so we can inspect the material, it's included in the assets. And there you go, it's just using the default particle material, just with the alpha on half, and that's pretty much it. So as you can see, just a very basic, very simple particle system. Now all we really want to do is just, for both of these, we want to enable or disable them depending on if the stove is on or not. So let's make a script to handle the visuals. So let's go down and create a brand new C# script. Let's call it the stove counter visual. Then let's go into the stove counter visual and let's attach the script. So here it is, attach it and open. Alright, so now here we just need references to those two objects. So as usual, let's make a basic serialized field. Let's make it of type game object. For the stove on game object, and the other one is the particles game object. Okay, let's save. And back here in the editor, let's drag the references. So the stove on visual and the sizzling particles. Okay, great. So now all we really need to know is when to turn these on or off. And for that is really going to be based on the state over here on the stove counter. So if it is on the state frying or fried, then we want to show them. If it is on idle or burned, we want to hide them. But as usual, we don't want to mix the logic and the visuals directly. So let's do that through a really nice event. Let's make a public event. Let's use a standard event handler. Let's call it onStateChanged. And let's also include the state on the event args. So let's make a public class, call it onStateChangedEventArgs, and let's expand event args. And then in here, let's just put a public state for our state. However, here we also have a really nice error. So this one is telling you there's inconsistent accessibility. Basically, that's because we made this one public. So any class, like for example our visual class, can indeed see this class. However, from outside, that class cannot see the private state. So that is why we have inconsistent accessibility. We cannot have something public which inside has something of a specific type which is private. So in order to make this work, we need to modify this state and make it public so that the other classes can see it. Okay, so that's great. Now let's just fire this event whenever the state changes. So over here, when you go into the frying state, let's go and invoke, and as usual, just this. And I actually forgot to add that, so let's go up here. Let's use the one with generics, so the onStateChangedEventArgs. Okay, great. So then down here, when invoke the event, let's create of this type. And inside passing the state equals this state. Okay, so this is all we need. So then down here, going to the burn state, let's fire the event. And down here, frying, fire the event, and on idle, fry the event. All right, that's it. So we have all of our state logic. And now over here on the stove counter visual, obviously we need a reference to the counter, so let's add that. So a serialized field, private, make it of type stove counter for the stove counter. And then we can do, and as usual, for accessing external references, let's do it on start. Go into the stove counter, and let's listen to the onStateChanged event. And over here, it's going to be very simple. We just want to show if it's on the state frying or fried, and if not, we don't want to show. So let's define a bool, call it showVisual. And this one is going to true if the e.state equals the state.frying, or e.state equals the state.fried. So if it's either of these, then this is going to be true. If not, it's going to be false. So then let's just go into the stove on game object and call setActive and pass in this. And same thing for the other one, for the particles game object. Okay, that's it. Super simple. Let's just drag this reference. So over here inside the prefab, just drag the reference. Let's leave the prefab, save the changes, and let's hit on play. And all right, so it starts off disable. Okay, so there's no visual. Now if I pick up and I drop it, and there you go, a nice visual. So the glowing red hot and the particles, and now it's frying. And if I leave it until it burns, when it burns, then it's going to turn it off. And if there you go, it turns off. All right, awesome. So now if I pick it up, wait until it gets cooked. So it's cooked, pick it up, and there you go, turns it off. All right, awesome. We've got a really nice visual. All that's left is to have a proper visual progress bar. And with this, we actually have another interesting clean code question. Right now, the progress bar that we made over here on the cutting counter, that one is great, so we would like to reuse that. However, if you look over here on the progress bar UI, we can see this is only working with the specific type cutting counter. So by default, this will not work with a stove counter. So as usual, we have multiple approaches to solving this problem. One option would be to simply completely duplicate this script. Then we would make a completely different progress bar UI class that would work only with the stove counter. So that's one approach that would work. And that approach might be good if you want the progress bar to behave very, very differently. But over here, I want both of them to behave exactly the same. So instead of having some code duplication, we can write some good clean code, but doing exactly what we did with regards to the kitchen object parent. Meaning we can use a nice interface we can then implement on anything that has some kind of progress. So let's do exactly that. First of all, let's actually go inside the cutting counter. So let's go inside the prefab. And over here, we've got the progress bar, and this one is just a regular game object. But since we're going to reuse this, let's make this a proper prefab. So let's find over here all of our prefabs and just drag the progress bar UI inside the prefabs folder. Okay, great. So this is now a proper prefab. Now let's define our interface. So let's create a brand new C# script. As usual, interface starts with I, so let's call it I. And for this one, we wanted to represent anything that has progress. So let's just call it literally has progress. Personally, I like to use the word has to indicate that a certain object has certain behavior. So in this case, objects that implement this interface will have some kind of progress behavior. So now over here for the interface, let's first make it so this one does not extend modified behavior. Instead of a class, this one is an interface. Okay, great. So now for the functions that we're going to need, If we look in the progress bar and we look at the cutting counter references, we can see the only one is literally just this. So we just have to listen to the event, and then the rest of the progress bar works inside of it. So realign the interface is the only thing we need to define, so let's actually go inside the cutting counter. So here we have the onProgressChange event, and then we have this, so we can literally just copy this, go into the iHasProgress, and let's put exactly this. Okay, that's it, that is literally all we need. Now if we wanted, we could also make a function to expose the progress amount, but since we included over here on the event, then we really don't need it, just this is enough. Now let's go over here on the progress bar UI script, and instead of working with the type cutting counter, instead let's work with a type that has iHasProgress. So let's rename this to hasProgress, and it's going to have the exact same event. The only difference is over here, instead of the event args being the one inside the cutting counter, is the one inside the iHasProgress. So let's make sure to change this, iHasProgress. Okay, so the signature matches. Let's just obviously rename this. So let's rename, instead of cutting counter, let's rename hasProgress onProgressChange. And that's pretty much it. We don't have any more errors, so everything over here is now working nicely with our interface. And back here in the editor, whilst we're still inside the cutting counter, sadly, interfaces do have one downside when it comes to Unity. If we look in the progress bar UI, down there we can see the progress bar UI, and previously we had the counter field exposed in the editor. However, now by changing into an interface, there we have the issue. The field does not show up here. Interfaces do not show up in the editor because Unity basically has no way of knowing that the interface will be implemented by some kind of game object. So sadly, this is the one thing that doesn't work very well with Unity. The solution that I normally do is actually pretty simple. Instead of exposing the interface, which does not work, instead let's just make this a regular private field. And then let's make a serialized field, and for this one let's make it of type GameObject, and let's call it hasProgressGameObject. Okay, so like this we have a regular serialized field with a regular GameObject. So if you look here, yep, we do have that field. So now we can indeed drag the cutting counter reference. And then over here in the code, in order to get the hasProgress, that is super simple. HasProgress, we just go into the hasProgressGameObject and get component of type iHasProgress. Okay, so that's it, now our code does work. However, of course, one big potential issue with this is that over here we have a field of type GameObject, meaning that we have no guarantee that this field does have a component that implements the interface. So we cannot make sure that we drag the correct reference. We can drag any reference, doesn't have to have our progress interface. So in order to keep ourselves safe, let's add a nice safety warning. So over here, if hasProgress equals null. So if this one is null, that means that that GameObject does not have any progress interface. If so, let's do a debug.log error. And let's say the GameObject, and let's pass in this GameObject, does not have a component that implements iHasProgress. So this way, if we make a mistake, we will have a nice error message. Basically, this is the one workaround that you need to use since Unity does not support dragging references in the editor if they are interface references. Okay, so with that, everything is good. So all of our progress bar UI, this should all be working perfectly. We just need to go over here into our cutting counter script, and let's make it so that we implement our interface, so iHasProgress. And we got an error just because even though we did define that interface member, the onProgressChange, again, keep in mind that the types depend on not just their name, but where they're at. So this type that we have here is the one that we define here, which is not the same one that we have here. So even though they have the exact same name, because they are in different places, they are actually different types. So we need to make sure to use the type in the interface. So over here, let's just go into the iHasProgress and use that exact type and get rid of this one. Okay, so that's it. That's a change we need. And down here when firing, let's just fire with that type. And down here, the same thing with that type. Okay, great. So like this, the cutting counter should still be working exactly the same as previously. Again, when refactoring any code, always do a quick test. So let's do that. Let's make sure to save our counter, save the prefab, go back outside, hit on play. Now let's pick up some cheese, put it there, cut, and there you go, the progress bar still does work. Okay, great. Now let's apply it to the stove, and that is actually going to be very simple. First, let's go inside the stove, so let's find the stove counter, let's open it up, go inside the prefab, and over here let's drag the progress bar UI prefab, so let's drag that. Then down here we already have the hasProgressGameObject, so let's drag the stove counter, and that's it. There's nothing else we need to touch here. We just need to go over here into the stove counter, and as usual, let's implement the interface. So the iHasProgress. And now let's implement it pretty much just like we did on the cutting counter. So we can actually just copy this. So we just need to implement the event. So that's it. And now for firing the event, let's go down and see where we are modifying all of our timers. So let's go down to when the player drops something. So we do the onState change, and now let's invoke this event. So this, and for the progress bar, for the progress normalize, this one's very simple. So just frying timer divided by the frying recipe SO dot frying timer max. Okay, that's it. We are modifying the progress. Now let's go up here when we are in the frying state. And when we do, let's fire off the onProgress change event. Okay, great. And finally down here when we have the frying, over here let's also fire, except obviously we have the burning timer and the burning timer max. And then just to make sure that the bar actually hides itself when we go into burned, let's also fire an event. This one doesn't have a timer, so let's just put it on 0F. Okay, that's really it. We don't need to touch the progress bar UI at all. Let's test this. Just make sure to save the prefab. Let's go back outside and hit on play. And right away, yep, the bar is indeed hidden. Now if I pick up some meat and I drop it, and there you go, got a really nice bar going up. And yep, going up on the burning state. And as it gets to the end, let's see if the bar hides. So it gets to the end. And yep, there you go, the bar does hide. All right, awesome. And if I pick up something, actually this was the one event that we forgot, so let's fix that. So let's just copy the one where we set the progress normalize to 0. And over here, if the player picks up something, let's set the progress back into 0. So here we are. Let's pick up some meat, drop it on there. Okay, let's wait for it to be cooked. Okay, it's cooked. Now before it burns, pick it up, and there you go, the bar is gone. All right, awesome. Okay, so here we have, again, another example of the power of writing good, clean code. We made a nice generic progress bar, and we very easily made it work with a completely different counter. Which of course would also work with literally anything that implements that interface. Doesn't have to be a counter. Now let me make one note here. Basically I showed you how to make a generic progress bar and reuse it. But let's say you want to do something specific just for the stove. Well, one approach, like I mentioned, is to duplicate the code and make a progress bar that works only with the stove. But another approach is to simply add more elements on top. For example, during the polish stage, we're going to do exactly that. We're going to add an extra UI element that will show up to warn the player when the food is about to burn. So I just wanted to point that out how you can mix and match both of them. You can have both generic components coupled with specific components. But for now, our progress bar, everything is looking pretty good. So let's leave that burn warning just for the polish stage. Now the next very important thing we need is some plates, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create the plates counter. This one is just going to spawn some plates, which we can then pick up to grab some objects. Okay, so let's begin making the counter as usual. So let's go inside our prefabs, inside our counters, right-click the base counter, make a new prefab variant, call it the plates counter. Let's go inside, and let's drag the visual for the plates counter. Let's go into scene view so we can see it. Okay, let's duplicate this, make this the selected. Let's go inside. And we can actually hide the circle sprite. We only need this one. So on this one, let's modify it for the counter selected. On the selected, let's make it just 1% bigger. And let's add the selected counter visual. Okay. Then inside, obviously, drag the reference for the kitchen counter. Okay, that's our basic setup. Now let's make our script to run this. So let's create a brand new C# script for the plates counter. Let's attach the script to the plates counter and open. Okay, now here as usual, let's extend our base counter. And then first let's handle the spawn timer logic. So basically we want to spawn some plates every once amount of time. So let's store a simple float for the spawn plate timer. Then let's make a simple update on timer. Let's increase the spawn plate timer by time.delta_time. And then just check if it's above a certain maximum. So if it is above something, in this case, we're going to have a fixed value, but still, like I mentioned at the very beginning of this course, let us not use magic numbers here. You should never use magic numbers. Instead, if you wanted to make it editable, you could also make it appear as a serialized field, but in my case, for the design that I'm going for, I'm perfectly content with having a fixed value, so just up here, pretty simple, the spawn plate timer max. And let's default it to 4F, and let's use it over here. Okay, great, so this is what we want. However, for spawning, it's actually going to be a bit tricky. The plate is supposed to be a kitchen object. The player should be able to carry the plate. And right now, for the design that we define, is that each kitchen object can only have one parent, and each parent can only have one object. But over here, we want to spawn multiple objects. Now let's quickly see what happens if we try spawning multiple as usual. So let's just go into the kitchen object, spawn a kitchen object. which means we need the plate SO. So let's do it up here. As usual, a serialized field private kitchen object SO for the plate kitchen object SO. So we're going to need to make this, and then we're just going to spawn this object on this. Okay, so this is going to throw an error, but still, let's see. Let's first create the object. Over here, let's go inside our scriptable objects, our kitchen objects. Let's create the brand new kitchen object. Call it just the plate. For the object name, this one is a plate. For the sprite, let's go with the plate sprite. And for the prefab, let's make it. So let's duplicate one of these, call it the plate. Let's go inside it, and obviously make sure to save the changes. Then over here, let's drag the plate visual, get rid of the tomato, and on the plate, let's make sure to assign the plate. And finally, let's exit this, let's make sure to save it, and on the plate, let's drag the plate prefab. Okay, so we have the kitchen object SO. Now let's just go inside our plates counter, and over here, let's drag the reference, so the reference to the plate kitchen object. Let's also drag the reference to the counter top point, then on the selected, drag the reference to our base counter, and finally start off with the selected disabled. Okay, so this should be working. Let's just add a plate counter over here onto our scene. So let's pick up a plates counter and put it somewhere in here over there on the side. So on an X of 7.5, then 0, and let's say on 0 maybe. Let's make sure we have space for one more counter over there. So let's duplicate this empty counter. And let's put it over there, pointing to the side. So this one is on 7.5, 0, and -2. Okay, so now let's just make sure that they perfectly match. So let's put this one on a Z of -0.5. Okay, so let's test. All right, so here we are, and look at that. And after 4 seconds, yep, there you go, it spawns the object. And then it immediately tried to spawn another one, and there you go, we have the error. Kitchen object parent already has a kitchen object. Basically, the way we designed our game and set up the code assumes that a single counter will only hold a single kitchen object, so we cannot have multiple plates on the same counter. Now, one solution for this problem is actually quite simple. When we spawn the plates, instead, let's not spawn a kitchen object. Instead, we're just going to spawn a dumb visual. Then when the player interacts with the counter, that is when we're going to spawn the proper kitchen object. So let's do that. Although again, let's keep the logic and the visual separate. So over here, let's first just handle the logic. So we just need to keep track of how many plates were spawned. So for that, let's store up here a private int for the plates spawned amount. And let's also do another private int for the plates spawned amount max. And let's say we can spawn at most 4 plates. Okay, so over here, instead of spawning the object, let's first of all actually reset the timer. So let's put it back to 0, 0. And on the plate spawned amount, let's check if this one is under the plate spawn max. And if so, let's go into the plate spawn amount and increase it by 1. Okay, so that's the logic, super simple. Now let's handle the visual. So let's first make our script. So let's create a brand new C# script for the plates counter visual. Now let's make sure to add the visual. So let's go inside the prefab, and over here we've got the visual. Let's attach it. Okay, open. Now here, basically the first thing we need is we need to know where to spawn the visuals. So let's actually add a reference to our counter top point. So let's add a serialized field for the private transform for the counter top point. Then let's also add a reference for the prefab we're going to spawn. So let's call it the plate visual prefab. Then here in the editor, let's drag the references. So the counter top point, place it in there. And for the plate visual prefab, let's go up here and find the visuals for the kitchen object. So these are just the visuals, and let's drag the plate visual. So the plate visual, not the plate kitchen object. Okay, now back in the code here, we obviously need to know when a plate is spawned. So let's go into the plates counter and make a nice event. So public event handler as usual, on plate spawned. And down here, let's just fire the event. So we just invoke with this and event args.empty. Okay, that's it, very simple. And then on the other script over here, let's just listen to it, which also means that we need a reference to our counter. So let's add over here the plates counter for the plates counter. So we're going to need to drag the reference, and then on start, let's listen to the on plate spawned event. And when that happens, then let's spawn. So let's call instantiate on the plate visual prefab. Let's put it inside the counter top point. So this is the transform for the plate visual transform. And that's pretty much it. Okay, so like this, it should be working. When the plate is spawned, we should be spawning a brand new visual. Back in the editor, we just need to drag the plates counter reference like that. Let's exit, save the prefab, and let's test. Okay, so here we are, and if we wait for 4 seconds, we should be able to see a plate spawn. Yep, there you go. And if we wait for a little bit more, we should also be able to see some more plates being spawned. Except we can't really see them. That's because we're spawning them on the exact same spot every time. But if we pause the game, and over here look in the hierarchy and find the plates counter, and inside the counter top point, yep, we do have 4 visuals. And if we wait for longer, then nope, it's not going to spawn anymore. It's only going to spawn 4 plates. Okay, great. So to solve the visual, let's just offset them by a tiny bit. To know how much we should offset, let's keep track of how many plates have been spawned. So let's store up here on the visual script a list of game object. Call it the plate visual game object list. Let's also make sure to initialize this. So let's do on awake. Let's initialize this list. And then when we spawn them, okay, so here we have the object that we spawned. Now basically we just need to modify the local position. And let's put it on new vector 3. On the X, let's put it on 0. Then on the Z, we're also going to have 0. And then over here on the Y, let's offset it by a certain amount. And basically it's going to be based on how many plates have been spawned. So let's define up here a float for the plate offset Y. Let's put it at, say, 0.1f. And over here, we're going to offset it by this much, multiplied by how many plates have been spawned. So we can go into our visual list.count. So you can do like this, and then we just need to add it to the list. So let's add this plate visual transform.game object. Okay, so now each game object should be spawned at a different height. So let's see. So here we are, and if we wait for 4 seconds, we should be able to see a plate. And there you go. And now after 4 seconds, we should be able to see another one placed slightly above, and yep, there it is. Okay, great. So everything is spawning perfectly, both in the logic as well as the visual. Now let's actually pick up a plate. So on the plates counter, as usual, let's implement the interact. So let's do a public, let's override the interact function. And now for picking up, let's first see if the player is actually empty-handed. So if, and we check the player has kitchen object. So if the player does not have a kitchen object, then the player is empty-handed. Okay, great. Then let's see if we have a plate that we can give them. So if the plate spawned amount, if it is bigger than 0, then there's at least 1 plate here. And if so, let's give it to the player. So how we do that is, well, over here for the logic, let's just increase it by 1. Then let's actually spawn the object. So on the kitchen object, let's spawn the plate kitchen object SO and spawn it on the player. And finally, we just need to update the visuals. So let's make another event. So up here on plate spawned and on plate removed. Okay, we have this event. And then down here, let's just, whenever the player picks it up, let's invoke this with this and event args.empty. Okay, great. So now in the visual, let's listen to this. So over here on start for the plates counter, listen to this event. And when this event happens, we just want to destroy the very last plate. So let's grab the game object for the plate game object, and we're basically just going to go into our list, so the plate visual game object list, and let's pick up the very last one. So let's go into the list.count -1, so this is going to be the very last element of the list. Then let's remove this one from the list, so plate.remove this one that we just grabbed, and then we simply call destroy on this one. Alright, so that's it, super simple. So over here on the plates counter, we do all of our checks, we cut it down by 1, we spawn the actual kitchen object, and we fire the event, and over here the event listens and updates the visual. Okay, let's test. So here we are, let's wait for a plate to be spawned, and when it's spawned, there it is, I'm going to pick it up, and yep, there you go, the player is now carrying a plate, let's drop it here, and there you go, there's another one. Now let's wait for a bunch more to be spawned. Okay, so the plates counter is full, now if I pick up, it should only eliminate the last visual, pick it up, and yep, there you go, it'll eliminate that one. Now I can drop it in there, and yep, there you go, another one spawn. Alright, awesome! Okay, so that's really it for the basics of the plate counter. It periodically spawns some plates, which the player can then pick up. Now in the next lecture, we're going to add the ability for the player to be holding a plate and pick up another object onto the plate. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add the ability for the player to be carrying a plate and pick up objects onto that plate. Okay, so here we already have the plate counter working. It has some basic logic. After a bunch of time, it spawns a plate. It spawns up to a certain maximum. and I can pick up a plate, and yep, the player is carrying a plate, so I can put it anywhere. Then I can, for example, pick up some tomatoes, slice them, and pick them up. However, now I am not able to place the tomatoes on the plate. So let's add that logic. Let's begin over here on the clear counter script. First, we're testing if there's no kitchen object here, and the player is carrying something, that the player drops something in there. But then we're testing if there is a kitchen object here, and if the player is carrying something. So it's over here that we want to check if the something that the player is carrying, if it is a plate. Now our plate is also going to have a bit of custom logic. So to help both identify and hold that custom logic, let's make a proper script to handle it. So back in Unity, let's create a brand new script. Call it the plate kitchen object. And let's open this. Now over here on this one, instead of extending MonoBehavior, we're going to extend kitchen object. So the plate is really just a more specific type of a kitchen object. Again, like I mentioned quite a while ago, you want to be very careful with inheritance. You need to have a very good reason to do it. Here we want the plate to behave exactly like a kitchen object, just with a tiny bit of extra logic, so in this case it makes perfect sense. Let's just go ahead and save this, and wait for Unity to compile. And over here, let's find our kitchen object with the plate, so here it is, the prefab. As you can see, we have a kitchen object. Now instead of having that one, let's replace that with the plate kitchen object. And since we are extending kitchen object, we have the same fields, so let's make sure to add the kitchen object as so, and get rid of the other one. Okay, great. So now back here on the clear counter, when there is a kitchen object here and the player is carrying something, we can check if the player is holding a plate, and for that we can check the type. So if, let's go into the player, and let's get the kitchen object the player is holding, and we test if this object is of type plate kitchen object. If so, then that means player is holding a plate. And if that is the case, then we basically want to give the player whatever object is over here, we want to add it to the plate. So let's go into the plate script to add that function. So over here, let's make a public void. Let's call it add ingredient. As a parameter, we're going to receive a kitchen object SO. We really only care about the type. We're going to destroy the actual kitchen object like we've been doing when creating different types. So the plate is really just going to store a list of types. So up here, let's store a list of kitchen object SO for the kitchen object SO list. Then when we add the ingredient, let's just add it to the list. So this kitchen object SO. Let's also make sure to initialize the list. So let's do it on awake. Let's initialize our list. And now from the other side, we just need to call this. So over here on the clear counter, if the player is holding a plate, let's first get the type of plate. So plate kitchen object, or the plate kitchen object. We go into the player to get the kitchen object, and we cast this as a plate kitchen object. Okay, so we have this, and then over here, let's call add ingredient. And let's add whatever is currently on this counter. So let's get the kitchen object and get the kitchen object as so. Okay, so we're adding it to the plate. And then let's destroy what is here. So get kitchen object and destroy itself. Okay, so that's it. So if there is something here, and if the player is holding something, and that something the player is holding is a plate, if so, we're going to add that ingredient to the plate and then destroy the object in here. So let's test. Okay, so here let's pick up a tomato, let's slice it, let's put it on a clear kitchen counter because that's the only one where we added the logic. So on this one, let's pick up a plate, and now whilst I'm carrying the plate, and if I approach and I interact with it, and yep, there you go, it does work. The object vanished from the counter and supposedly was added to the plate. Again, we can use a really nice debug inspector to see it. So let's pause the game, let's select the plate, let's see the plate kitchen object, so here it is, this one, and let's change the inspector into debug mode, and down here, yep, we do see the kitchen object as a list, and it does have some tomato slices. Okay, awesome. So with this here, we have our basics. We can have some ingredient, and we can basically pick it up from a plate. Now, one thing about our plate, this is where we're basically going to carry the final recipe that we're going to deliver to the customers. And based on the design that I defined, I want something pretty simple, meaning for the design that I'm going for, there won't be any kind of double burgers or double cheese. So each final recipe will only have at most one of each ingredient. So let's add some basic logic just to prevent adding duplicates. Over here on the plate kitchen object, when we add an ingredient, since the function will now not necessarily succeed every time, let's actually rename this. And again, use the very useful Visual Studio shortcut. So you can press Ctrl+RR or right click and let's rename. Since this function will no longer succeed, we're just going to try to add an ingredient. So try add ingredient. And then let's also make it return a boolean. Basically for any function where you're not sure if it will succeed, I like to add try and make it return bool. So this way it works pretty much exactly like the try again component that we've already seen so many times. So it tries to do something and returns whether it succeeds or not. So over here, instead of always adding the ingredient, let's see if this one is a duplicate. So let's do an if, and let's go into the list and check if the contains. And if the list already contains this kitchen object SO, if though, then already has this type, so let's return false. And if not, then that means this is a brand new ingredient. So let's add it and return true. Okay, so that's it. Now let's go over here onto the clear counter. So we try to add the ingredient, but then we only want to destroy if this one succeeds. So let's put this one inside an if. So if we do manage to add the ingredient, then yes, let's destroy itself. If not, then we don't destroy anything. Okay, so let's test. So let's go ahead and slice 2 tomatoes. So one, slice it, put it here. Then another one, slice it and put it here. Now let's pick up a plate, go up here, try to pick up this one, and yep, it does work. Now for this one, and nope, it doesn't work. Okay, great. Now, one more thing in our logic. We only want to pick up certain things. Like I said, only things that won't be used in the final recipe. For example, no customer is ever going to request a full entire tomato. The recipes only have sliced tomatoes, so we should not be able to drop a full tomato directly on top of a plate. So let's change that. So over here on the plate script, let's basically just create a list of our valid ingredients. So let's make a serialized field, private, make it a list of kitchen object SO, and call it the valid kitchen object SO list. Okay, so we have this list. And over here in the editor, let's just drag the ones that we want. So let's first of all select the plate object. Okay, here is the plate prefab. And over here we've got all of our kitchen objects. So let's just drag the ones that we want to add to the plate. So the final recipes will have some bread, yep, but they will not have entire cabbages. They will only have cabbage slices. Same thing, no cheese, only slices. For the meat, we're only going to be able to add meat cooked, but also meat burned. Then we're not going to be able to add a plate onto a plate, of course not. And finally, instead of a tomato, just tomato slices. Okay, that's our valid list. And over here, again, it's very simple. So we can just go, if the valid kitchen object SO list, if this one contains the one that we want to add, then we can add it, but if not, then let's return false. Not a valid ingredient. Okay, so let's test. Alright, so let's pick up a tomato and also some tomato slices. And now if I pick up a plate and I go into the tomato, nope, doesn't work, but the slices, yep, it does work. Okay, great. So here we have all of our basic plate rules. Everything is working perfectly, but it's only working over here with the clear counter. So let's do a little bit of code cleanup, and then let's add this logic to all the other counters. So first, to clean up this code, over here we are testing if this is a plate kitchen object. Then we cast to an object, and then we call the function. So let's simplify all of this. And let's do it just like Unity does with their try_get_component function. So let's make a custom function that takes an output parameter. The best place to put it is on the kitchen object. So here we've got the kitchen object script. Okay, great. Let's scroll down and make a nice function here. So let's make a public. We're going to return boolean in case this succeeds or not. Let's call it try_get_plate. And over here, let's make an out parameter. So don't forget the out keyword. Let's return of type plate kitchen object for the plate kitchen object. And over here, we do exactly what we did. So we test if this object is a plate kitchen object. If so, then let's set the plate kitchen object equals this as a plate kitchen object. And we return true. But if not, then this is not a plate. So let's return false. And one thing when working with output parameters, you always need to make sure to set the output before you exit the function. So over here, that's the error that it's telling us. We must assign it to something when we return. So over here, we don't have a plate kitchen object. So to solve this, we just set this to null. Okay, great. Now over here on the clear counter, instead of doing all of this, basically let's ask the player if this is a kitchen object. So let's try to get the plate. Out plate kitchen object for the plate kitchen object. So you try to get it, then we try to add the ingredient, and so on. Now obviously we could further simplify things by making a function that would try to get the plate and try to add the ingredient. That could work, but since some counters are going to have a bit more custom logic, I think keeping them separate like this makes more sense. So first we try to get the plate, then we try to add the ingredients. So let's apply this same logic to the cutting counter. So over here on the cutting counter, let's scroll down to where there is a kitchen object here and the plate is carrying something. So on the clear counter, we just want to copy all of this. So let's go over here and we do the exact same thing. Okay, that's it. And the other counter from where we can pick up things is from the stove counter. So here we are on the stove. Let's scroll down until we find the interaction. Okay, there's something here. The player's carrying something. So it's over here. Let's do that and do the exact same thing. Except on the stove, again, let's remember that this is using a state machine. So when we pick up something, let's do pretty much the same thing that we did here. So let's make sure to reset the state, fire the events, and so on. Okay, so those are the only counters that we need to implement. We cannot drop things on top of a container. We cannot drop things on top of the plate counter or the trash. So these are the only 3 types that we need to implement. So with this, let's test. Okay, so let's begin with some meat. So let's pick up some meat, put it on the stove. Let's pick up a plate, wait for it to cook, pick it up, and yep, there you go, it does work. Now let's test the cutting counter. So let's pick up some cheese, let's slice it, pick up some plate, and go, and yep, there you go, it does work. And again, if we inspect, we can make sure that it is indeed working. So let's go into the plate. And let's put this on Debug Inspector, and yep, there we do see this one has a meat patty cooked and some cheese slices. Okay, great. Now the last piece of logic that we need is pretty much the opposite. So right now it works if there's a sliced object on the plate and the player is holding a plate object. But now we want the opposite. So let's say there's a plate in here, and we slice some cheese, and now I want to drop the cheese on the plate. So let's do that. And basically for this one is only going to happen on the clear counter. That's the only counter type that can have a plate on top of it. So over here on the clear counter, then we check if there's no object there, but that's not what we want. We want if there's a plate on the counter. So if there is an object there, and if the player is carrying something, then we check if the player is holding a plate. But if not, so if the player is not holding a plate, so player is not carrying plate, but something else. Over here, we need pretty much the exact same logic, except just testing for the object on this counter. So let's do if, let's get the kitchen object on this counter. This one tried to get the plate. So out plate kitchen object for the plate kitchen object. So if so, there's a plate over here. That means the counter is holding a plate. So then let's go into this plate kitchen object. Let's add the ingredient. And we're going to try to add whatever the player is currently carrying. So the player dot get kitchen object and get the kitchen object as so. So we're going to try to add this. And if we can't add, then we're just going to destroy whatever is on the player. Okay, that's it. And over here we've got a nice error just because we defined it with the same name up here. So up here we're already defining the variable, and over here we're defining the same variable with the same name. So we can either give this a different name or just not define a brand new variable here. So just it's defined up here and we're using it here. Okay, so all logic is working. Now here, make very sure that you're not mixing references. Keep in mind when you're referencing the kitchen object on this counter and the one on the player. Those are 2 different things. So over here, if the player is not carrying a plate but something else, then you check the kitchen counter. So over here, you're not checking the player but checking the counter. Then you go into that plate and you try to add the ingredient, and you try to add the one that the player is carrying, and then you destroy the one the player is carrying. So again, be very careful here. Make sure you don't mix references. So with this, it should work. So let's make sure to save our script and let's test. Okay, so here we are. Let's first pick up a nice plate. Let's drop the plate in there, pick up some bread, drop the bread, and yep, there you go, it does work. Alright, so now we can do a bit more natural interactions. So for example, let's pick up some meat and put it on cooking. And there you go, the meat is fried, so now I'm currently carrying just some meat. So I place it there, then I pick up some bread and put some bread on top of the meat. And yep, everything does work flawlessly. Okay, so here we created a plate, and we created some custom logic to define what the plate can and cannot pick up. Now all that's left is actually being able to see what is on the plate, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add a nice visual to our plate. Okay, so right now we can already pick up ingredients onto the plate, so if I pick up the plate and I pick up some cheese, there you go, there's some cheese on the plate, but we cannot see it, so let's solve that. And the way we're going to do that is actually in a very simple way. If you look in the included assets inside the prefab visuals, there's this nice plate complete visual that I built. Basically, it's a full burger that contains all of the ingredients. What we're going to do is actually very simple. We're just going to enable or disable these game objects. That's it. So let's do exactly that. Let's make a new C# script. Call it the plate complete visual. Let's attach a script over here. And let's also make sure to put this one inside the plate. So let's save this prefab. Let's go inside the plate prefab. So inside the prefabs, here the kitchen objects, we've got the plate. So inside the plate, let's drag that. Let's drag the plate complete visual. Okay, great. So now let's open up this script. Over here, let's first add a reference to our plate kitchen object. So a serialized field, private for the plate kitchen object for the plate kitchen object. Back in the editor, let's drag the reference. Okay, great. So now here, basically, we need to update this visual whenever the plate gets any ingredient added to it. So let's go over here into the plate script and basically just need to fire off an event when that happens. So let's make a public event handler, and let's call it on ingredient added. Okay, and for this one, let's also make an event args to contain the data of what object we added. So let's make a public class on ingredient added event args. Let's extend event args, and inside let's make just a kitchen object SO, kitchen object SO. Okay, great, and let's make the event of this type. All right, so now let's just fire off this event. So down here, when we try to add an ingredient, if we do add the ingredient, let's fire off this event. So let's invoke with this, and let's create a brand new one, passing the kitchen object SO as this kitchen object SO. Okay, so we have our event correctly being sent. Now over here on the plate complete visual, let's listen to it. Again, as always, let's make sure to do it only on start. So the plate kitchen object on ingredient added, let's listen to this event. And over here, we just need to either enable or disable the visuals that relate to the kitchen object inside over here, the event args. However, of course, the question is, how exactly do we find them? The plate complete visual has all of these game objects. How do we know which one belongs to that kitchen object? Now, technically, one way would be to do a simple transform find and find the child objects by name. Technically, that would work, but like I mentioned in the beginning of the course, strings are a horrible way to identify things. They are very error prone. So let's not do that. Instead, let's use a proper approach where we can define some kind of link between a kitchen object SO and a game object. And we can do that very easily by just defining a struct. So up here in our script, let's do exactly that. Let's define a public, make it a struct, and name it kitchen object SO underscore game object. Then inside, it's very simple. We just have a kitchen object SO field, and then also a game object field. That's it, super simple. By the way, if you don't know what is a struct, basically it's very similar to a class, except it's stored in different places in memory and behaves somewhat differently. I have a very important video on that subject, what is the difference between value types and reference types. Classes are reference types, so when you pass in a class into a parameter, you are passing in a reference to that object. Whereas structs are value types, so when you pass in a struct onto a parameter, you are passing in a copy. It's a bit of a tricky thing, so definitely make sure you go watch that video for more detail so you don't get confused in the future. Here I defined it as a struct simply as kind of a teaching moment, but also because it just makes sense that if I just want to store some data without any logic, then it should probably be a struct and not a class. Although in this case a class would work just as well. Anyway, so here we have a struct. Inside the struct, we have a field of type kitchen object SO and another one of type game object. So now let's just make a list of this type that we can expose in the editor. So up here, a serialized field, private, let's make it a list of kitchen object SO game object and call it kitchen object SO game object list. Okay, that's it, super simple. So let's save and make sure this compiles. So actually, let's just comment this out, just make sure our code compiles, okay? And over here in the editor, we see the tricky thing when it comes to using fields of custom types. If we look in the inspector, nope, we don't see anything, so we cannot see our custom type in the inspector. If you make a custom type like this struct, and you want to show it in the inspector, then you need to add the attribute serializable, which exists inside system. So let's go up here using system, and let's add the attribute serializable, just like this. Okay, so do this, save, and let's look. And if there we go, now we do see our custom struct. So we've got a list, and we can click on the plus icon, and there you go, we've got an element, and it does have a field for a kitchen object SO and one for a game object. So that's great. With this now we have a really nice place where we can link one object to another. So let's just do exactly that. So for example, let's put the bread over there, and let's assign the kitchen object SO for the one with bread. Let's do the same thing for all of the others. So let's add a whole bunch more. Okay, so we've got the bread, then we're going to have the meat patty cooked, then the tomato slices, then we have the cheese slices, the cabbage sliced, and finally the meat patty burned. So we've got numbers 0 through 5, so we have 6 elements, and over here, yep, we do got 6, so we have all of them. We can get rid of these last 2, okay, great. And now let's assign the proper objects, so this one for the meat patty cooked, then we've got the tomato slices, then we have the cheese slices, then the cabbage slices, and finally the meat patty burned. Okay, great, so all of the references match. Now back in the code here, so we have this list fully filled out. And when we have this, really very simple, we just cycle through the list to find the right game object. So let's do a for each of type kitchen object so game object in our kitchen object so game object list. And we check if this kitchen object so dot kitchen object matches the one that we received in the event. If they do match, then go into this one, grab the game object, and set active into true. Okay, so that's it, some very simple logic. And also we can start with them disabled by default in the editor, or just over here, just do something very simple. Just do a for each, cycle through every single one of them, and set every single one of them to false, so that they are hidden. Okay, so with this, all the ingredients on the plate should be visible. So here in the editor, let's just make sure all the references have been set. Let's go back, save the prefab, and let's hit on play. Okay, so here we are, and by default, look at that, an empty plate, and yep, it is empty. And now let's slice some cheese. Now let's place some cheese on there, and yep, there you go, we've got some cheese. Now let's pick up some bread, drop some bread, and there you go, got some cheese and some bread. Then let's cook some meat. So let's cook it, and let's pick it up with a plate. And as soon as I go, boom, there you go, I've got a nice cheeseburger. All right, awesome. So with this, I can now do a complete burger, so let's finish it. Let's just add some more tomatoes, so slice them and add the tomatoes. And finally, some sliced cabbages, slice them, put them there, and there you go, here we have a fully complete burger. Okay, so that's great, all of our visual logic is indeed working. However, this visual is a bit hard to see, it's not very clear to the player. So just looking at it from this distance, does that have a tomato or not? There's a tiny sliver of red in there, but you can't really see it. So we should probably add some nice clear icons on top to clearly indicate what exactly is on this plate. So that's exactly what we're going to do in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some really nice icons on top of our plate so we can easily see what is on there. Okay, so for the icons, let's do the exact same thing that we did for the progress bar, meaning let's use a world space canvas. So let's go inside our plate kitchen object prefab, and over here let's right click, let's create a brand new canvas. Let's name this the plate icons UI. Then for the settings, let's make it world space, put it on 0, 0, everything, width and height also on 0. Then let's lift it up a little bit, so put it on a Y of 1, okay, like that. Now inside, let's define an icon. So let's start by making an empty game object. Call this just the icon template. Let's put it with a size of 0.3.3, so okay, something like that. Then inside, let's add a new UI image, name this the background. And make it stretch to fill the parent, so put 0 on everything. Okay, there's our background. For the background image, instead of a square, let's actually go with a circle. For that, Unity actually has a bunch of built-in sprites that it added in the last versions. However, it's not actually over here by default. In order to see those default sprites, we need to install the 2D sprite package. So let's quickly just go into Window, Package Manager. Let's make sure we are in the Unity registry, make sure we are looking at all. And over here, let's find the 2D sprite package. Okay, so let's install this. Okay, there's the package. So now if we go into the background and we search for a sprite, and over here, make sure you click to actually show the assets from the packages. And now we see a bunch of default hexagons, a bunch of isometric tiles, a square, so on. And if we search for a circle, yep, here we've got a bunch of circles. So let's use this one over here on this path, so let's use it. There you go, we have a nice circle. Now let's duplicate this image, and for the second one, let's name it icon. And for this one, let's assign just a random sprite, so let's say the bread. And again, remember how the sorting order on the UI, this one is based on the order in the hierarchy. So make sure that the icon is underneath the background in the hierarchy, that way it shows up on top. Okay, so we have our icon template, that's great. Of course, we're going to dynamically generate all of this through code. We're going to have multiple icons, and for positioning them, Unity actually has some really useful components. Let's select the plate icons UI, and over here let's add a component. Now for example, a built-in component is the grid layout group. This basically helps you position all of the child objects. So let's put the size of the canvas over here on 0.9.9. Okay, so there you go, a nice square window. Then over here on the settings for this, for the cell size, let's put it at 0.3.3. And if there you go, already shows up over there on the corner. And we can see what it will look like if we just duplicate this object. So let's make a bunch more templates. And if there you go, that's what it looks like. So as you can see, this component is super useful for automatically positioning all of the child objects. Now if we want to, we can play around all of these. We can add a little bit of spacing on the X or on the Y. But let's actually leave both those with 0. Let's leave everything on defaults. Just over here on the child alignment, let's put it on middle center. Okay, so there you go. That looks pretty nice. So you can see how this built-in component is super useful. There's actually 2 more. So this one for the grid layout, this is great when you want to put things horizontally and vertically. But if you just want horizontally, then there is the horizontal layout group. And if you just want vertically, there's the vertical layout group. So all of these components are really awesome, really useful. Okay, so with this, our objects are placed. And note how I named this an icon template. Basically, a template is just what I call something that is kind of like a prefab, but not really a prefab. Through code, we're going to duplicate this template and dynamically modify the icon. So we're going to use it very much like a prefab. We could actually make this into a proper prefab, so I could just drag it over here onto the project files and make a regular prefab. That could work, and the only reason why I prefer this method of not using a prefab is just because this object, this template, stays here on the object as opposed to cluttering over here your project files. If you have tons of single-use UI elements with tons of objects you need to spawn, you can end up with tons and tons of prefabs, and you might not even know where each of those is used. Whereas with this method, the template stays exactly where it's used and does not take an asset slot over here on the project files. So personally, this is just the approach that I prefer for spawning UI elements, but like I said, prefabs work as well, so if you prefer using prefabs, go ahead and make it. Okay, so let's make our script to run the plate icons UI. So let's go into our scripts, and on the scripts folder, let's create a brand new C# script for the plate icons UI. Over here, let's attach a script and open it. Okay, so now the first thing we need is a reference to our plate. So let's begin by making a serialized field private for the plate kitchen object for our plate kitchen object. Okay, let's save it and drag the reference. So over here, there's the plate icons. Let's just drag the plate reference. Okay, great. Now on the plate, we already made this event when an ingredient is added. So basically, we just need to listen to this in order to add the new icon. So over here on the UI, let's do, as usual, private void start. And on start, let's go into the plate kitchen object and listen to that event. And when that happens, let's spawn an icon. Although here, let's actually use a different method from the one we used on the plate visual. Over here on the plate visual, whenever we had the event, we really just modified the object that was added. So over here, the equivalent would be to spawn a new icon whenever that one was added. But instead of doing that, right now let's listen to this event, and when this happens, let's update all the icons in this display. Basically, this other method is useful when the contents can be added as well as removed. Now in this case, they are never going to be removed, so in this case, both methods work fine, but still I want to show you the second method just so you can use it when you need it. So for that method, we just need to know exactly what is on the plate. So over here on the plate kitchen object, we just need to expose the kitchen object SO list. So let's do exactly that. So public, we're going to return a list of kitchen object SO. Let's call it get kitchen object SO list. And we just return the kitchen object SO list. Okay, very simple. Then over here on the plate icons UI, let's just make a function to update the visuals. So private void, let's call it update visual. And when we have the event, let's call our update visual. Okay. So now here, let's basically just cycle through all the ingredients. So let's do a for each kitchen object SO in the plate and get the kitchen object SO list. Okay, so we're cycling through all of the ingredients on the plate. And then we want to duplicate our template. So that means we need a reference up here. So let's add a serialized field, private, type transform, call it the icon template. Okay, and let's save the code. And over here in the editor, let's drag the reference. So let's drag the icon template. By the way, I left the others over here. That's not a problem since these are going to be destroyed, those we're going to see in a little bit. The only one that matters is the first one. Okay, so here we have the icon template. So to spawn it, we do it just like we do with any prefab. So we just call instantiate, pass in the icon template, and then transform parent, so let's put it as a child of this object. This part is important. We need to make sure the object is spawned as a child of this object. If over here you put something like null, then the template won't be spawned as a global object, so it won't be somewhere in the world. So in order to make it positioned properly, let's make sure to use transform to become a child of this object. Okay, and then since we're using the other script, the grid layout group, this is already going to be automatically positioned. So just like this, it should be spawning the icon. And with the icon spawned, all that's left is really just setting the image. And now again, the quick and dirty approach would be over here when we spawn. Let's say we pick up the item transform. And over here, we could go inside and do a find in order to find the image, in order to get the component of type image and so on. So that is one approach. That would be the quick and dirty approach. But again, we want to do things properly, so let's do it the proper way instead. So instead of this, let's make a proper script that we're going to run on the icon template. So let's create a new script. So a new C# script, call it the plate icon single UI. So this one represents just a single icon. Let's go ahead and attach it to the template. So over here, let's drag it. And now when using this template method, really the only one we need to worry about is this one. The other duplicates, we can just leave them. They don't really matter. But still, just to avoid any confusion, I'm actually going to delete them. So okay, we just have one icon template, okay, and it has our script. Okay, let's open. Now over here, let's basically just make a function to set a kitchen object SO. So public void, let's call set kitchen object SO. And we receive parameter of type kitchen object SO. Okay, great. So then we need to set the image. So let's just go into a serialized field, private of type image, which is inside unityengine.ui. So for this one, for the image, we have a reference, and then we set the image.sprite, go into the kitchen object and grab the sprite. Okay, so all we need to do is drag this reference. So over here in our template, let's drag the icon image. Okay, great. So now back here on the plate icons UI, so we spawn it, that's great. Then let's do a get component in order to get our script. So the plate icon single UI, okay. And then we just call set kitchen object SO and pass in this. Okay, that's great. This is much better. Now again, you might be thinking that this method is a lot more verbose than just setting the image sprite here. We had to create another completely new script. We had to write this logic and over here get it and use it. The quick and dirty approach would indeed be quicker, but remember that while the quick and dirty approach might be faster at first, it will mess you up over time. So just take a few extra seconds to do things properly. This approach is much more scalable. Let's say, for example, on this function, you want to change not just the sprite, but also trigger some kind of spawn effect or animation. With this, it's very simple. We've got this function right here. We receive the kitchen object SO, and we can do whatever we want with it. So like this, we have this script that is responsible for anything related to the single template. And we've got the general one, which just spawns them and just gives them the kitchen object SO. So all of our logic is nicely separated. Okay, so just like this, it should already work. However, like this, you might already be thinking, won't this spawn way too many icons? And yep, it will. Basically, every time we add an ingredient, we're updating the visual, where we're cycling through every single one and spawning all of them. So with this, we're constantly going to spawn more and more items. This is not what we want. Over here on the update visual, we do want to update and spawn all of the icons. But before we do that, we actually need to clean it up. We need to clean up the icons from the previous event. So before we do that, let's just cycle through all the children on this transform. So that's pretty simple. You can just do a for each transform child in the transform. So this way cycles through all the children. And then just call destroy on this child.gameObject. So that won't work. That won't destroy all of the previous children. However, of course, we also have one issue. The icon template itself is also a child. So if we do this, we're going to destroy the icon template, which then over here we're going to have an error because we're going to instantiate null. So we want to destroy all the children except for the template. So over here, that's pretty simple. We just check if the child equals the icon template. If so, then let's just skip it. So we can just call continue, and there you go, it skips. Okay, great. So just one more final thing. If we leave the template like this, meaning the game object is enabled, like this, the template will always be visible, plus whatever ingredients we have. We don't really want the template to be visible. This is just meant to be a template that we can instantiate. So that's pretty simple to fix. Let's make a private void awake, and on awake, let's grab the icon template, grab the game object, set active into false. Okay, so now the icon template won't be disabled, so it won't be visible. And then over here, when we are instantiating, the instantiated ones will also be disabled. So let's make sure we go in there and enable these. Alright, that should do it. So all of our logic should be working. There's only one more tiny thing we need to take care of. This one is a world canvas. So like we saw with the progress bar, we need extra logic to make it look towards the camera. And thankfully, we already wrote an excellent generic script to do just that. So let's go into the plate icons UI, and let's add a component, and let's add our very nice look at camera. So like this, and let's set the mode the same that we use, so let's put it camera.forward. Okay, so everything is great, everything should be perfect, so let's finally test. Let's leave the scene, save the prefab, and hit on play. Alright, so let's go pick up a plate. And there you go, there are no icons visible. Okay, that's great. Now I'm going to place a bread on top of the plate. And there you go, I've got a nice bread icon. Okay, great. Now let's make some meat, cook it, and as soon as it's done, I'm going to pick it up. And there you go, I've got a bread and some meat. Now let's put some cheese, slice it, put it there, and there you go. Now I can easily see that plate has some bread, some meat, and some cheese. Now let's just add the rest of the ingredients to make a full mega burger. So let's add some tomatoes and add some nice cabbage slices. And yep, there you go, it works perfectly. So here we have a complete burger with everything, and we can easily see on the icons everything this contains. Alright, awesome! Okay, so here you'll learn how to make yet another super useful element that you can easily add to all of your games. Personally, I use this kind of logic a ton in all kinds of UI things. For example, in my upcoming Steam game, Total War Liberation, the items in the inventory, they're all added using this method. So there's a template and I duplicate that template. Same thing for all of the action buttons. All of those are based on having a template and duplicating it. It's a really easy way to do this kind of thing. With all of that, here we have a full plate and we can easily see what is on there. So with this, the next obvious step is to actually deliver some orders. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to build the delivery counter. This is where we're going to drop some items that the customers have requested in order to complete the orders. Also, just for fun, we're going to learn how to use ShaderGraph to make a simple custom shader. Okay, so let's begin by making our counter. So let's go into our base counter, let's create a new prefab variant for the delivery counter. Let's go inside and now let's find the visual for delivery counter. Let's duplicate it to make the selected. Let's go inside, modify the material. Then on the selected, make it 1% bigger, 101, add the component, the selected counter visual. Let's drag the kitchen counter like that. Okay, that's our basic setup. And also start with the kitchen counter disabled. Okay, great. Now let's make a script to run this. So let's go into our counters folder. Let's create a brand new C# script for the delivery counter. Let's attach it and open. Okay, so now here as usual, let's begin by extending our base counter class. All right. Now let's override the interact function. And for now, let's actually do it exactly like the trash counter, meaning let's just destroy the object. So we just check if the player is holding something. So if the player has a kitchen object, let's go into the player, the kitchen object, and let's destroy it. However, another rule over here for the delivery counter is this is only going to accept plates. So let's see if the player is carrying a plate object. So player get kitchen object and test try to get the plate. So out plate kitchen object for the plate kitchen object. We try to get this, and if it is a plate, then we destroy it. Okay, that's it. Here in the editor, let's just compile the script and drag the references. So the counter top point, and on the selected, let's drag the counter reference, and let's exit this, save the prefab. And let's drop it over here on the corner. So let's find over here the delivery counter. Let's put it over there. Angle it on this side. Put it like this. Let's also just quickly reposition all of our counters, since we already have all of the types that we're going to use. So on delivery counter, let's put it over here on this corner. So X 7.5, 0, and Z of 2. Then next to it, let's put the plates counter. So over there, okay. Then next to it, let's put a clear counter. After that, let's put the trash counter. And then let's also put another empty one there. So let's duplicate this one, move it up to about this and put it like that. Now we just need to move all of these down here. So just select all of these counters and let's move them down by about this. Okay, so on minus 5.5 like this. Okay, so everything is nicely positioned. Just over there right now we cannot access that container. So let's actually modify those as well. Which by the way, over here there's the canvas in front. So as I click, I'm actually selecting the canvas in the hierarchy. So here's a quick inti tip. On the hierarchy, on the left side, you've got these two buttons. So one of them hides the object and the other one simply makes it unselectable. So if I click on this and I click through, and the click goes through the canvas. So that makes it much easier to select over here all the items in our scene. So let's just select all of these. Okay, all of these. Now just push them all to the side and make another empty one and put it over here. Okay, that's a nice layout. Now let's just finish the rest. So over here, let's just duplicate our empty counters and place a bunch more. Let's put one more to the side. And now these ones over here, so let's put it over there and rotate it here. And duplicate another one, and another one, and another one, and just one more. And get rid of this one. Okay, great. So here we have pretty much our complete map. Let's also just move the camera a tiny bit, just make sure that it is nicely organized. So put it over there just so everything is nice and centered. Okay, so there's our map. Now let's get back to working on our delivery counter. We already added this code, so let's just quickly test. So here we are, and if I pick up something like, for example, some cheese, go into the delivery counter and interact, and nope, nothing happens because that one only accepts plates. Now if I pick up a plate, go there, deliver, and yep, there you go, it does work. Okay, great. So this is the basic logic that we want. For defining the actual recipe logic, we're actually only going to do that in the next lecture, but for now, let's add one more nice thing. Let's add a simple custom visual over here using Shader Graph. This is a great way for you to learn the power of Shader Graph and just how easy it is to use. This is a visual tool for making shaders. It's really very easy. Personally, I don't know how to write shaders with code, but I can build some pretty nice things using Shader Graph. As usual, I have a dedicated video on it. I also have an entire playlist showcasing how to make all kinds of interesting effects, and even one special video covering some changes in recent Shader Graph versions. So over here, let's learn the basics how to use it. So first, here in our project window, let's create a brand new folder. Let's name it just shaders. And now inside, let's create one. So let's create, then go up here into Shader Graph. Then we're using URP, so let's go inside there. And here we've got a bunch of options. Now don't worry about picking the quote-unquote wrong option. All this does is just create a template. So for example, if you accidentally create an unlit shader, you can then easily swap it out for lit. So right now, let's go with the unlit shader. And for the name, let's name it moving visual. Okay, there's our Shader Graph file. Now let's just double click to open it. And up here we have the nice Shader Graph window. By the way, you can make this full screen. So you can either right click over there on the tab and maximize, or alternatively you can just click on this window and you can use the hotkey Shift Space. And yep, there you go, it does maximize. Okay, great. Now by default we have this down the center. This is called the master stack. These are the actual properties that we're going to need to use. Then on the left side we have the properties blackboard. On the right side, we've got the Graph Inspector. And finally, down here, we've got the main preview. All of these windows can be scaled. And also, if you don't see these windows, or if you accidentally hide them, they're all up here on these three buttons. So the blackboard, that's on the left, the Graph Inspector, and the main preview. Okay, so now here we've got a nice empty board, so we can add whatever nodes we want. So we can right-click and go into Create Node, and then we can write something, or just click anywhere and press on space, and there you go. Now we can cycle through and browse all of these menus to see all of the nodes that exist. There's tons and tons of them. Or alternatively, just go up here and use the search bar. So for example, let's find the sample texture to the node. So here it is, this one. Okay, we've got this node. What this one does is it takes a texture and grabs the color from it. So on the left side of the node are the inputs and on the right side are the outputs. Within the parentheses, you can actually see the types. So for the input texture, this one is of type T2, so that means it's a texture 2D. Then on the output, you can see there's a 4, meaning it contains 4 floats, which in this case refers to the 4 colors. So that's red, green, blue, and alpha. So for an input, we want a texture, so let's set it over here as a property. Let's click on the plus icon, and we've got a whole bunch of types. For the texture, we want a texture 2D, so let's go with that. And then for the name, now usually there are two standard names. There's one called main text or base map. Main text used to be the more common name, but when working with URP, for some reason they decided to name the main texture as base map. So over here, let's stick within the URP standard and just call this base map. Okay, there's our property, and if we click to select it, and on the right side we can see the Graph Inspector, and we can see all the properties for this actual property. So we see a name, reference, and a bunch more things. Now the really important one is over here, the reference. This is the actual name that you're going to use if you want to interact with this shader through code. The name on the property, this one is just a text string, so this can be whatever you want. You can even have spaces and so on. Whereas the reference name, this is the really important one. And by default, when you set up a name, it should already set the correct reference. Usually the standard is to name it just like the name, both without any spaces and with an underscore in the beginning. So just like this. Okay, then we can give it a default texture. So let's go ahead and select something. For example, over here, the bread texture. Remember, this is just the default. This will not be hard-coded directly into the shader. We can then modify this. Okay, so we have our nice base map property definition. Now we can just drag it over here on the board, and yep, there it is. And now we can just click on the circle icon in order to drag a connection, and let's connect it over here onto the sample texture to the input. And yep, right away we do see it does work, so we are correctly sampling the texture. However, if you look on the main preview, over here there's still nothing. That's because we don't have this node connect to anything. We need to connect it to the final master stack in order to render something. So again, on the output over here, we can see a 4. So these are all of our colors. And actually, one very useful node is the preview. Since so many things in Shader Graph can be hard to visualize, So we can move these nodes around, and let's add the preview node. And this does exactly that. So you can feed it an input, and you can see down here what that input contains. So for example, let's drag just the red channel. And if there you go, over there we can see the red channel for this texture. We can drag the green channel, the blue channel, or look at the alpha channel. Yep, there you go, it does work. So this preview node is super useful for being able to see what your shader is actually doing. Over here we have the colors, so let's get rid of the preview right now. And in order to make it work, we really just need to connect the RGBA and go up here into the base color. And right away it should work, but you might not be able to see anything over here on the main preview. I believe this is a rendering bug in the current tech version, so right now nothing is shown. So if you still don't see anything, it's actually pretty simple. Just go up here on the top left side and make sure to save the asset. Okay, save it, great. Then let's exit from our maximize view. And now let's close this tab. Let's click on play just to play the game. Now let's stop playing. And now if we open the shader again, yep, there you go. Now we do see the shader compiling over there, that color, that is the shader compilation. And after a little bit, it should work. Let's just maximize this. See, if there you go, there we do see our texture. Okay, great. So again, this is just a simple rendering bug on the current tech version. If you're watching this video in the future, chances are you don't even have this bug, so there's no need to worry. Okay, so right now we do see it working. We can see our bread texture, and it's currently being applied on a sphere. For our use case, we're working with 2D textures, so this would be best to be seen on a quad. So we can right click over here on the preview in order to select the preview mesh. So let's go with a simple quad, and yep, there it is, we have our nice quad. Okay, great. So over here we have our basic shader. All it does is just shows a texture, that's it. Now let's actually use this. And first, let's always make sure to save the asset. On the top left side, on the moving visual, if you see an asterisk here, that means you have unsaved changes. So always make sure to save them. In my case, I don't, but still, never hurts to save. Now over here in scene view, let's go inside our delivery counter, so let's open it. And now for the display for our arrow, let's make it a flat quad. So let's right click in the hierarchy, let's create a new 3D object, and let's make it a quad. Let's call this the delivery arrow. Let's place this on top of the counter, so let's rotate it to face upwards. By the way, on the rotation, make sure the color is facing upwards. Most shaders by default, they only render one face and not the other one. So make sure you put the face with the color upwards and not the other one. Okay, so let's rotate this one upwards. So there you go, 90 over there. And let's just put it just exactly on top of the counter, so just enough so that it's visible. Okay, great. So now let's make a material for our arrow. So let's go inside the materials folder, and over here, let's create a brand new material. Let's call this the delivery arrow. Let's make sure to use this material on the quad, so let's just drag it over there on the mesh render. Okay, so it's using our custom material. And over here on this shader graph drop-down menu, over here we can select what shader we want to use. So in our case, let's go inside the folder shader graphs, and inside, yep, here we have our moving visual shader. So let's go ahead and use this. And yep, right away we do see that it does work. Here we have our texture being drawn exactly on top of our material. Okay, so far so good. Now again, here remember one very important thing that I said. The texture that you define the shader, over here the default for the property, this one is only the default. The important one is the one that we have on the material. I'm emphasizing this point because I've seen a bunch of people make this mistake. If you modify default texture whilst inside the shader, like for example if I change here from bread, let's say into the cabbage slices, if I modify that, note how it does not modify any materials that were created. We are only changing defaults. So if you want to change the texture that is actually used, make sure you change the one on the material that you created and not the default. I changed the default but did not change this shader. However, if I now were to make another material, which by the way, here's a quick tip, you can right click directly on the shader file and go into create and create new material, and it will automatically create the material using that shader. Actually here it didn't update default just because I didn't save the shader. So I modified this one for the cabbage slices, and now if I save the asset, and now if I right click there and I create a brand new material, and yep, now that one does have the new default. But again, remember, what you set over here is just the default. What really matters is what is on the material. After the material has been created, modifying the default here does nothing. So always keep that in mind. In most cases, you want to be changing the property on the material itself, not the default on the shader. Okay, let's just clean up both of these. All right, so let's continue. Now here we have our sprite working, okay, except we don't want to show some bread, so let's actually use the proper arrow sprite. So let's select this one. And yep, it does work, it is printing the sprite. However, one obvious thing is that the arrow is not transparent like it should be, so let's solve that. Back in our shader graph, in order to make this a transparent shader, we need to actually go into the graph settings. So on the graph inspector, go into graph settings, and over here you see a bunch of settings that relate to the graph itself and not any selected property. So let's go into graph settings. For example, like I mentioned a while ago, you can modify between lit and so on. So this is where you would change that. You can also up here add multiple targets. So you can create a shader in shader graph and make it work with the universal render pipeline or the high definition render pipeline or the built-in render pipeline. All of those are supported through shader graph. Now for our goal, in order to make this a transparent shader, let's just go over here onto surface type. Instead of opaque, let's change to transparent. And as soon as we do, look what happens there. And if there we go, it adds a brand new alpha channel. If we just save the asset right now, and nope, look at that, it still doesn't work. It's still not transparent. Basically, we made this shader transparent, but now we need to feed in the transparent channel over here onto the alpha. This is the one thing that is different from a previous version of shader graph. Previously, you could just feed the alpha channel over here onto the base color, and shader graph would automatically apply it. But in recent versions, you need to add it over here separately. So if you have any issues with transparency when following some older shader graph tutorials, always remember this change. I covered that along with some other changes in a very useful video. So if you're following along some older shader graph tutorials, make sure you watch that video to learn what you need to do to update them to the latest version. Okay, so here on the sample texture, we already have the alpha channel, so we just connect this onto the master alpha. And right there, we already see it working. Let's just go ahead, save our asset. And here in scene view, yep, there you go, now we do see our arrow. Now, one more small thing. You might notice that from some angles, it's not exactly transparent. Basically, it actually is transparent, but since we made this a lit shader, sometimes the light might make the transparent parts visible. One option to solve that is over here on the graph settings. Instead of making it lit, let's make it unlit. That would work. So yep, with the unlit shader, the transparency is perfect. But if you really want to keep it lit, then the other thing you can do is just over here play around with these settings. You've got smoothness, AO, and so on, and over here you can even modify the workflow mode. So for transparency, instead of making it metallic, let's go with a specular workflow. And then over here, set the smoothness to 1 and the ambient occlusion down to 0. And now if we save this shader, and look at that, and yep, now the transparent parts are indeed fully transparent. Finally, over here on the right side on the mesh render, if you want, you might want to play around over here with the cast shadows. So maybe you don't want this one to cast shadows, maybe you don't want it to impact light probes, and so on. Okay, so with this we have our nice transparent arrow. Let's make sure to save our delivery counter, so let's go outside back into scenes, and let's hit on play. And yep, there you go, we have our transparent counter with our nice arrow. Now we want the arrow to actually move. And doing that is actually super simple. Going back here in our shader graph, let's just modify default just so we can see the arrow that we want to see. So let's select the arrow sprite. Okay, there's our arrow. Now for moving, over here on the sample texture, we've got an input for the UV. The UV is what defines what portion of the texture we're going to grab, which by default just gets the whole texture. So since this field represents where we're going to grab from texture, by playing around with this we can grab different parts. So to do that, let's just add a standard UV node. So here it is, this is the standard UV channel. So if we connect this, then nothing changes, everything still renders exactly the same. But now we can modify this, and to do that, we're really just going to use some basic math. Remember that when working with shaders, even though you do see colors, everything is really just numbers. So a UV2 is just a number, the color is just a number, the alpha is just a number. So visually, everything might look like images, might look like colors, but really in the end, it's all just numbers. So for example, how do we move this texture? Well, it's actually pretty simple. We just add a number onto it. So over here on the UV, let's just add an add node. So this just adds two numbers together, very basic. So let's take the regular UV and let's add something on top of it. For example, we can make a vector 2, and let's put it on, say, 0.10. And let's add this one onto this one. And now if we drag this one onto the input, look over there on the preview what happens. And if there you go, look at that, it moves slightly to the left. So if I modify this one, put it on 0, there you go, at that, 0.1 on that, 0.2 on that, and so on. So you can see that by modifying here, I'm essentially offsetting the texture. I'm offsetting on the X, and over here I can also offset it on the Y. Basically, I'm offsetting the texture by 10%. The UV is a normalized value, this is not pixels. So that is why 0.1 is 10% regardless of how big the texture is. And if we go way past 1, then the texture essentially loops back. So this is really all we need. For our moving arrow, we're going to have 0 on the Y, and on the X, we're going to constantly either increase or decrease. That's how we're going to have our moving arrow. So again, the only issue here is that I'm modifying this manually. We don't want a fixed amount on the shader, instead we want a nice animation. So for that, we have the very useful the time node. This one has various time-based outputs. The one that we want for this case is the time, which is just the total time. This one is constantly increasing since the start of the game by the number of seconds. So if you use this over here directly on the ad, and there you go, look, that texture is constantly scrolling. Okay, so that's great, except obviously we have one issue. We don't want it to scroll diagonally. We only want to scroll in one direction. So for that, we can essentially create a simple property to act as our speed. So let's over here on the blackboard, let's create a new vector2, call it our speed property. And for default, let's default on say 0.1 on the x, 0 on the y. And now if I drag the speed over here onto our blackboard, okay, great. This is basically a multiplier, so we just need to multiply the time by this. So let's add a multiply node. Also, by the way, quick tip, over here on each node, you've got a nice little arrow, so if you want to make it a bit more compact, so if you don't actually need to see the preview, so make that. And in this case, let's take our time, multiply by our speed, and then for the output, pass it into the ad. Okay, so look at that, now it is indeed moving in this direction. And over here on the speed, we can play around the values. So if I put it at 0.5, now it's moving faster. And if I put it on the y, now it's moving diagonally, put it 0 on the x, and now it's only moving vertically. Okay, so this is really what we want. Let's just go ahead, save our shader, and now let's just select our delivery arrow material. And over here, yep, we've got the speed. If you don't see it, make sure that on the speed property over here you have it exposed. So we have the speed, instead of moving on the y, let's move on the x. And actually like this, it's reverse going backwards. So over here we can just put a negative value. So let's put it on -1. And if there you go, now the arrow is moving perfectly. Also here, let me make one important note. Just in case you're using this shader with a custom texture instead of the one included in the course, if you do that, make sure that the texture that you use, so over here I'm using the arrow texture. Over here on the arrow import settings, down here under wrap mode, make sure it is set to repeat. If you set it as clamp, you might get some weird visuals or nothing at all. In order for the texture to constantly loop and constantly repeat itself, that one needs to be set to repeat. Okay, so here it is in game and we have a really nice moving texture. For that, we created a simple but really nice, useful custom shader. Definitely go ahead and watch the various effects that I made in the shader graph playlist. This tool is super useful, definitely make sure you know how to use it. I've used it for making a building effect, I've made some nice outlines, a really nice wind shader, also a really interesting dissolve effect, and even a cool transition shader just like in the game Hades. So this really is a super powerful tool, make sure you watch that playlist to really learn how to use it. Alright, so here we learned about shader graph and created a really nice custom shader. However, the delivery counter still only has a visual, so let's create some proper logic for generating and delivering the correct recipes in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to build a proper delivery manager that will generate recipes that the customers are ordering and validate to see if the player made the right dishes. Alright, so right now we have the player capable of making dishes. So for example, I can put some cheese, cook some meat, cut the cheese, and then pick up both of them. Then let's say pick up some bread, and there you go, got a nice cheeseburger, and deliver it. Okay, so that works, but right now they just vanish on the delivery counter. So there's no recipe we need to follow, no validation, none of that. So let's add both those things. Okay, first of all, let's make our script. So let's create a brand new C# script for the delivery manager. Let's make a new game object to run it. So a new delivery manager, attach the script. Let's make sure to keep things clean, so reset the transform. And also, by the way, since we're here, let's go ahead and put the plates and delivery counter inside the counter so everything is nice and organized. Okay, great. So let's open up this script. Now here, basically we need to define some sort of list to store all of the recipes that the customers are waiting for, which of course begs the question, what type is that going to be? Now, technically, one thing we could do, since a recipe is really just a list of kitchen objects, over here we could have a list of kitchen object. This would be our recipe list. Technically that would work, but that really looks quite dirty. Instead of having a list of a list, we should probably have a proper type for this. So let's write some good clean code and define a proper recipe scriptable object. Back in Unity, let's go inside the scriptable objects folder and create a brand new one. Let's call this the recipe SO. And over here, let's make this a scriptable object. So extend scriptable object, make the create asset menu. And now over here for the fields, for the data that we need. Really, like I said, a recipe is just a list of ingredients. So just a list of kitchen object SO for the kitchen object SO list. Okay, that's it. That's really all the data that we need to define a recipe. Just to be able to identify them for the player, let's also add a public string for the recipe name. So just a nice name string. Okay, great. Now back in the editor, let's define. So let's go inside the scriptable objects and make a brand new one for our recipe SO. And now inside, let's create a brand new recipe SO. For this one, let's call it just burger. And over here, first of all, for the name, just name it burger. And then for the kitchen object list, well, to make a burger, first let's add some meat. And we want some cooked meat. We don't want to serve uncooked or burnt meat, so only the cooked meat. Then for a simple burger, obviously we need some bread, and that's about it. So some bread, some meat, that's our very basic burger. Now let's also make another one, so let's duplicate this one and name this one the cheeseburger. Over here, let's name it cheeseburger. And like name implies, has bread, meat, and obviously some nice cheese slices. So there you go. Okay, we have a cheeseburger. Now let's also make a mega burger, so something with everything. So let's call this one the mega burger. And over here for the string name for the mega burger. And for that we have meat, bread, cheese. Let's also have some nice cabbage slices and also some tomato slices. Alright, that's our mega burger with everything. And finally, let's also make just a nice simple salad. So let's duplicate this for a salad. Let's name it salad. And for the salad, we don't have any meat, we don't have any bread, and also no cheese. So just cabbage slice and tomato slice. That's a simple salad. Okay, so here we have all of our recipes. So back here on the delivery manager script, instead of making a list of game object, let's just make a list of recipe SO, and name it the recipe SO list. This is where we're going to place the recipes that the customers are waiting for. So let's actually rename this. Let's put it waiting recipe list, okay? So the customers are waiting for whatever is inside this list. And now we could make this a serialized field and set it in the editor, but we don't want to have a fixed list. We want to periodically spawn new recipes. And in order to spawn new recipes, we also need to know which ones we can spawn. So for that, we could add a list of all of the recipes. Then we could pick a random one from the list and add it over here to the waiting list. That would work, that's one good approach. But since we already did something similar to that various times in this course, here let me teach you a different approach that sometimes might make more sense. For that second approach, we just need one thing. We need a scriptable object to hold all of our recipes. So let's do that. Let's do a brand new C# script. This is the recipe list scriptable object. And then inside, this one is going to be a scriptable object. Let's add the create asset menu. And inside, we're just going to have a list of recipe SO. For the recipe SO list. So that's it, super simple. Now let's just create one object of this type. We can put it inside the recipe SO list since we're only going to have one. So let's make a recipe list SO, name it the recipe list SO. And then over here, let's just drag our recipes. So we've got a burger, a cheeseburger, we have a mega burger, and finally a salad. Okay, so basically we have a scriptable object with all of our recipes. And now, just for safety, since we only want to ever have a single one of these objects, a recipe list SO, for this one we can go back here in the script and simply comment out the create asset menu. So now back in the game, over here we can no longer create another type of recipe list SO. So just a nice safety thing since we probably only need just one. And let's also add an underscore just so it shows up at the top of the list. Okay, great. So we have this, and now over here on the recipe manager, we can basically expose that in a serialized field. So let's make a serialized field, make it private of type recipe SO list, recipe list SO, for the recipe list SO. And now here in the editor, we just drag that reference. Alright, that's it. So basically the difference that we did with this method is over here on delivery manager, instead of having a list of all of our recipes, we just have a reference to one object, and then that object holds a list of all the recipes. In this specific use case, like I said, this approach doesn't really have many benefits compared to just storing the list here. But let's say we had another script that also needs a list of all of our recipes. If we did that, we would basically have duplicate references. So this script would have a list of all the recipes, then some other script would also have a list of all the recipes. And then if you wanted to add a brand new recipe, you would need to add it to all the lists on all the scripts. Whereas like this, any script that needs to know about all of the recipes just needs a reference to the recipe list SO. And whenever we want to add or remove a recipe, we just need to update this one object and everything works perfectly. That's one of the benefits of this approach, where you have a scriptable object to hold a list of all of the objects of some type. Personally, I find this pattern to be quite useful. Okay, so on Delivery Manager, we have a list of all of our recipes. Now let's just make a simple timer to spawn them. Like I mentioned previously in the spawn point logic, you could just use a coroutine if you like that. Coroutines can be useful for running timers, but personally, like I mentioned, I do not like coroutines. I don't like the pattern they force you to use. So over here, I'm just going to make a simple float timer. So a private float for the spawn recipe timer, and another one for the recipe timer max, and let's say 4 seconds. Then we just do a simple private void update. On update, let's count down the timer, so time.delta time. And if the spawn timer is under 0F, let's reset the timer. And now let's basically spawn a recipe. So for that, let's grab a random one from the list. So we go into the recipe list SO and grab the recipe SO list. Then we're going to grab a random one. So let's get a random index. So random.range between 0 and the recipe list SO dot recipe SO list dot count. So you get a random one. This is going to be a recipe SO for the waiting recipe SO. And then we simply go into the waiting recipe SO list and we add a brand new recipe. Okay, that's it. Super simple. Let's just make sure to initialize the list. So let's do here a simple awake for the waiting recipe SO list and just initialize it. Okay, so like this, it should be working. However, we're also going to generate recipes nonstop. We don't want that, so let's define some kind of maximum. So let's define a simple int for the waiting recipes max. Let's say we can have a maximum of 4 recipes waiting. And then down here when timer elapses, so if the waiting recipe SO list.count, if it is under the maximum, then we generate and add it. Okay, that's it, pretty simple. Now for testing, let's just add a log here to print the name. So debug.log on the waiting recipe SO that we generate. So let's print out the recipe name. Okay, so let's test. So here we are, and yep, one was spawned right away. So we have a salad, and after 4 seconds, yep, there you go, another salad. And if we wait for 4 seconds, we should have another one. There you go, a mega burger recipe. And finally, after 4 seconds, we have another burger. And now, no matter how much time passes, there should be no more since we're at the limit. And yep, time passed and no more. Okay, all right, awesome. So we are correctly generating recipes that the customers are waiting for. Now let's add logic to try to fulfill these orders. So over here on Delivery Manager, let's make a function to deliver a recipe. So let's make a public void, make it public since we're going to access this from the delivery counter. Call it deliver recipe. And the recipes are going to be delivered whilst on a plate. So let's receive a parameter of type plate kitchen object. And over here, the logic is actually going to be pretty simple. We just need to cycle through all of the recipes that the customers are waiting for and see if the ingredients on this plate matches the ones on any waiting recipe. So over here, let's cycle through all of our recipes. So let's do a for int I at 0, going through the entire recipe list.count, I++, okay. Let's grab the recipe SO for the waiting recipe SO. And we grab from the waiting recipe SO list on this index, okay. So we have that. Then first, let's do a quick test just to check if the waiting recipe has the same number of ingredients as there are on the plate. If not, then we already know that it's not valid. So over here, let's do a quick test. So waiting recipe SO, let's check the kitchen object SO list.count. If this one matches the plate kitchen object, let's get the kitchen object SO list and also check the count. So over here, we know that has the same number of ingredients. So this is the first check. Then we need to cycle through all of the ingredients on this recipe and all of the ingredients on the plate and basically see if both of them match. So let's first cycle through the ingredients on the recipe. So for each kitchen object SO, let's call it the recipe kitchen object SO in the waiting recipe. So let's go into the waiting recipe and get the kitchen object list. Okay, so here we are cycling through all ingredients in the recipe. Then we need to cycle through all of the ingredients on the plate. So let's do another cycle for the plate kitchen object SO. And we're going to go inside the plate kitchen object, get the kitchen object SO list like this. So here we are cycling through all the ingredients on the plate. Okay, so now here basically we need to see if this ingredient that we're cycling through, if this one matches the ingredient on the recipe. So here we check if the plate kitchen object SO, if this one matches the recipe kitchen object SO. If so, then the ingredient does match. So in order to keep track if it does match, over here before we cycle through all the ones on the plate, let's define a bool for found or ingredient found. Let's default it to false. And over here, if we have a match, then this one becomes true. And by the way, over here, we can also break out of the cycle. Now, if you're not familiar with break, basically this is going to break out of the for each. So let's say the plate has 10 ingredients and the second one matches. When this cycle gets to the second one, it triggers a break, so it no longer goes through the remaining 8. So basically it breaks out of the cycle, so it keeps writing some code right down here. Okay, so we cycle through all of the ones on the recipe. Then we cycle through the plate, and if we do find that ingredient on that plate, then we have an ingredient found. So over here, if we have a not ingredient found, Then over here, that means this recipe ingredient was not found on the plate. So if that happens, then essentially over here we have a fail state. So the ingredient that this recipe requires is not on the plate. So let's go up here. When we have the same number of ingredients, let's define a boolean called the plate contents matches recipe. Let's default it to true. And over here, if we don't find at least one of them, then the plate contents do not match the recipe. And afterwards, we can check this bool again. So if this one is true, that means they all match. If just one of them does not match, then this one won't be false. So over here, we know player delivered the correct recipe. So over here, let's do a quick debug.log and print out a message. And after we do, let's also do a return so we stop the rest of the execution. So basically, if we find a waiting recipe that matches, we don't want to keep going. And also here, if we do find it, let's also remove it from the list. So let's go into waiting queue, remove at, and remove at this index. Okay, so we're going to remove this recipe. But if this doesn't happen, then it's going to keep cycling, and it's going to cycle through all the recipes. So basically, if it reaches the end of this for, then basically no match is found. So the player did not deliver a correct recipe. So let's do another debug.log in here. Okay, so this is all of our logic. It looks a bit complex, but I hope this was easy to follow. When we see it in action, it all becomes a bit more clear. So all that's left is just calling this function from the delivery counter, so let's do that. Over here on the delivery counter, it accepts plates, it destroys plates, but before we destroy, let's go into the delivery manager, which means we need to access a reference. So again, we could add a serialized field, or in this case, it makes perfect sense to make this a singleton. So let's make it here, public static of type delivery manager, call it instance with a public get and a private set. Okay, then over here on awake, let's set instance equals this. All right, so now over here on the delivery counter, we can go into the delivery manager, access the instance, and deliver our recipe and pass in the plate kitchen object. Okay, that should do it. Let's test. All right, so let's look in the log to see what they are waiting for. So there are 2 cheeseburgers waiting, another mega burger, and a cheeseburger. So let's make a cheeseburger to deliver. So first of all, let's cook some meat. Let's slice some cheese. Let's pick up the meat before it burns, pick up the cheese, and we just need the bread. Okay, this is a valid cheeseburger, so let's deliver it. And if there you go, the player delivered the correct recipe. Okay, great. Now let's deliver something that nobody asked for. Let's say just some meat. Actually, let's burn it just for fun. Alright, so there we have a bunch of charred meat, so nobody really wants this. But if we deliver, yep, there you go, player did not deliver a correct recipe. Alright, awesome, so over here everything worked. We have a bunch of recipes being generated. And then we have the logic so that when the player delivers something, it checks if the player delivered something correct or incorrect. So everything is great. All that's missing is obviously some nice UI, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create a nice UI visual to display our waiting recipes. Okay, so our delivery manager is already working. We are randomly spawning some random recipes every once in a while. Now instead of looking at the console, let's add a proper UI. So for that, over here in the editor, let's go inside the canvas. And by the way, let's click on the button to unlock the canvas. And this is actually the first time we're using the regular canvas. Quite a while ago, we just created it. We didn't really set it up, so let's quickly do that. For the render mode, this one is meant to be a regular UI, so let's leave it on the screen space overlay. Then over here on the canvas scaler, instead of constant pixel size, let's go with scale with screen size. Then for the reference resolution, I like to use 1920 by 1080. And finally, I like to fully match with the height. Basically, this means that objects in the canvas will only be scaled if the height changes. For example, let's add inside just a quick UI image just to test. Let's look in the game view. So there you go, there's the image. Let's just put it on a different color. Okay, so there's the image. And note how if I modify the aspect ratio here, so let's say I put it on 5:4, there you go, the horizontal size of the window changed, but note how the element was not scaled. So I can put it even on free aspect, so really wide and does not change the size. Whereas if I modify this, if I modify the vertical size, the image does indeed get scaled up or down. Personally, I like this setup because it means that I only have to worry about positioning things horizontally. If the vertical part gets changed, everything gets automatically scaled. Okay, so great. So over here, let's go back into Full HD, all right, and let's get rid of the image, all right. Back in the scene view, Let's quickly look at the canvas. So we can select the canvas, press the F in order to zoom out, and also we can press the 2D button up here to go into 2D mode. Okay, so here's our nice UI. Now inside the canvas, let's create an empty game object, call it the Delivery Manager UI. Then in the inspector, let's make it stretch to occupy the whole thing. So let's put 0 on everything. Okay, so this window now occupies the entire screen. Now inside, let's do just like we did a while ago for the plate icons, meaning let's make the template that we can then clone, but let's also put those templates inside of a container. So first of all, let's make the container. So a new empty game object, call it just the container. The reason why I'm going with this approach is because I also want to have other objects outside of here. If you remember how we did with the templates, we can actually go there and see. So let's go inside the prefabs, inside the counters. Actually, it's on the kitchen objects. So let's go inside the plate. Over here for the template, basically we use the plate icons UI, this main canvas as the container. But if you remember how we did that, in order to make sure we didn't end up with duplicate icons, we always destroy the previous one when we spawned a brand new one. So every time we were cycling through the children of this object in order to destroy all of them except the template. So over here we're going to use a container so that we can apply that logic only to the children of the container, and that way we can have other objects outside of the container. For example, outside of here, let's say we want some nice text just saying recipes in waiting. So on the Delivery Manager, let's make it a child of that one. Let's go into UI and let's make a text Mesh Pro. And this is the first time that we're using Text Mesh Pro, so this window pops out. Let's actually import the Text Mesh Pro Essentials. Okay, just let it import. Okay, that's it. We don't need the examples or extras, so let's just close this window. And over here on this window, let's name this the title text. Let's set the text to something like recipes waiting. Let's put it up there on the corner, so let's anchor it on the top left corner. Also for the text, I like to put it on a width and height of 0, but of course that makes the text really vertical. So then down here on the wrapping, let's just disable it. So there you go, looks like that, and let's put it over there on that corner. Now in scene view, we are seeing things different. So if you want to see what this looks like, just go into the game view, and over there, yep, we do see the recipes. Let's just make it in bold. So there you go, just some nice text. Okay, so that's our text. And then for the container, let's make inside the delivery template. So let's create an empty game object. Let's call it the recipe template. And for this one, we're going to want to anchor it to the top left corner. So with the template selected over here in the inspector, let's click, and we want to click up here. However, we also want to set the pivot. So let's make sure to hold down Shift in order to set the pivot over there. Okay, great, that's exactly what we want. So we want the template right in the corner. Then let's give it a size of, say, 250 by 100, okay? Now inside the template, we just need two things. We want the name of the recipe as well as the list of all the ingredients. Although before that, let's actually make a nice visual for the background. So a new UI image for the background. Let's make this one stretch to occupy the whole thing. Let's put everything on 0. Okay, that's the background. Let's put it on a black with just a little bit lower alpha. Okay, that's good. Then for the name, let's make a text field. So inside the template, let's create another text. Call it the recipe name text. Then over here, let's put it a bit small. So on a font size of maybe just 20, let's put it in bold. And let's also again put the width and height of 0. And over here, make sure to disable wrapping. Okay, so that's the text. So we've got it up there. Let's just anchor it to the top left corner. Okay, great. Over here, we can change the name to recipe. And then what we need is the icons down here. And for that, we're going to do pretty much the exact same thing that we did on plate. But before we do that logic, let's just get this basic setup working. So let's just position everything. So first of all, the container for all the templates, let's anchor it on the top left corner. And let's push it all the way over there. And for positioning them, let's use this time the vertical layout group. So inside, let's duplicate the template just to be able to see them. Okay, so that's pretty much what we want. We can actually set the width and height both to 0. And let's set the spacing to something like 30. Okay, so that's our basic UI. Now let's make the script to run this. So over here in our scripts, let's create a brand new C# script for the Delivery Manager UI. Let's go into the parent game object and let's attach the script. Let's open. Okay, so now here, first we need a field for the container and another one for the template. So let's do a serialized field, private transform for the container, and another one for the transform, and this is going to be the recipe template. Then let's do pretty much the same thing we did previously. So first of all, let's actually go on awake in order to hide the template. So game object set active into false. Okay, so first we hide the template. Then let's make an update visual function. So private void update visual. And for updating, we're going to do the exact same thing that we did. So first, let's cycle through the container and destroy everything except for the template. So do a for each transform child in the container. And if the child is the template, if so, then we're going to continue. And if not, we're going to destroy the child game object. Okay, so we have the cleanup. Now all we need is to cycle through all of the waiting recipes. So that means that over here on Delivery Manager, we need to expose our waiting recipe SO list. So let's go down here, make a function to do that. Public going to return a list of recipe SO, get waiting recipe SO list, and we just return the waiting recipe SO list. Okay, great. So now here on the UI, we can now go into Delivery Manager, access the static instance in order to get the waiting recipe SO list. So let's cycle through this. So do a for each recipe SO in the waiting recipe SO list. And for each of them, let's instantiate and let's spawn our recipe template, spawn it inside the container. And then we just need to set this to enabled. So let's grab the transform for the recipe transform. We grab this one, grab the game object and set active into true. Okay, so like this, the only thing missing is the text, but that's okay for now. Let's just see where we're going to call this function to update the visuals. And as usual, we want to be smart and write some good clean code. So let's not do the dirty approach of just updating this on every single update. Instead, let's only call this function when something actually changes. So over here on the Delivery Manager, let's just make some simple events. So public event handler. Let's call on recipe spawned. And another one, call it on recipe completed. And actually, as soon as I add the event handler, which also add the using system, now here we have an interesting thing. We've got a nice namespace collision. It's telling us that random is an ambiguous reference between UnityEngine.random and system.random. That is because both these namespaces, UnityEngine and system, both of them have a class named exactly random. So the code here does not know which class we're trying to use. To solve this conflict, we really just need to be more specific. In this case here, we want to use the UnityEngine version, so let's just write the full name, UnityEngine.random. And yep, that works. Okay, so now let's fire off the events. So first of all, the onRecipeSpawn. So over here, when we spawn a recipe, let's invoke this event. So this event_targs.empty. And let's also get rid of the log. We no longer need that. Okay. Now we could also add the waiting recipe on the event targs, but in this case we don't need it. Just firing the event is enough. And then down here, when the player delivers something, if the player delivers the correct recipe, we remove it from the list. And then let's fire off the event. So on recipe completed, let's invoke with this and event_targs.empty. Okay, so we have the event, and down here we also don't need a log. Okay, so that works. And finally, over here on the Delivery Manager UI, let's just make a private void start. On start, going to Delivery Manager, access the static instance, and listen to both these events. So the spawned, and let's also listen to the other one. So Delivery Manager instance on recipe completed. When either of these work, let's just go and update the visual. So just like this. Let's also rename this because again, instance doesn't sound like a very good name. Let's actually rename this to Delivery Manager. And same thing up here. By the way, I'm using the Visual Studio shortcut, Control-RR, in order to rename this to Delivery Manager. And finally, we also need to update the visual on start, just to make sure the previous ones do not show up. Okay, that's it. So like this, it should be working. We should be able to see no visual, and then as more are spawned, we should be able to see each one being spawned until the maximum. So let's see. Just over here in the UI, let's make sure to drag the references, so the container and the template, and let's hit on play. And okay, right away, actually it spawned one recipe, it spawned instantly. Then after 4 seconds, there you go, a second one. And after 4 seconds, we should be able to see, yep, another one. Now 4 more seconds, and we should see the final one. And now, no matter how long we wait, it should no longer spawn anymore. And yep, that works. All right, awesome. So the basic logic is working. Now let's handle the proper logic on the template. For that, like I mentioned previously, one approach would be over here. You could go and do a transform.find, find the actual recipe name text, then get the text mesh component and set it. That would work, but like I mentioned previously, that would be very dirty, not good at all. We should avoid using find at any time, and we should also avoid the individual logic from the total logic. So let's do it properly and make a proper script to handle each spawn template. So let's create a brand new C# script. Call this Delivery Manager Single UI. Single just because it refers to a single recipe. And also right now we already have quite a few UI scripts, so let's organize our project again. So let's organize a new folder for the UI, And inside, let's put all of our UI scripts. So delivery manager single, this one, the plate icons, and the progress bar. So let's put all of these nicely organized in the UI folder. Okay, so with the script, let's go into the recipe template and attach the script. Now let's open. And over here, let's begin by adding a field for our text. So a serialized field. And over here, it's also very important. For the text, we are not using the text inside Unity Engine.ui. This is the legacy text. It is not TextMesh Pro, so this is not what we were using. Instead, we want to use TextMesh Pro UGUI, which is inside TM Pro. So we need to go up here and add using TM Pro, and now we can use this type. And also make sure you're using TextMesh Pro UGUI and not TextMesh Pro. This one also exists, but don't mix these two. These are two very different types. If we go over here in the editor, and if outside the canvas, if I just create a new 3D object, a new text object, if I do that, then if we look over here in the inspector, we see this one is of type TextMesh Pro. Whereas for the ones that we're using inside the canvas, if we look, this is TextMesh Pro, it's a UI text. So these are the two different classes within TextMesh Pro. You have TextMesh Pro and TextMesh Pro UGUI. We're working on the UI, so we want this one. Okay, so we named this the recipe name text. Okay, that's it. Over here in the editor, let's drag our reference, all right. So in the script, let's make a function to set the recipe. So a public void, and let's call it set recipe SO. And we're going to receive a recipe SO. Then we just go into the recipe name text, and we set the text to recipe SO.recipe name. Okay, so that's pretty much it. Now over here on the UI script, when we instantiate our recipe transform, let's get component of type of our delivery manager single UI and call set recipe SO and pass in the recipe SO. Okay, so let's see if the name shows up. And yep, right away it does show up. So we can see that we generated a cheeseburger recipe and right now a mega burger recipe. Okay, great. So all that's left are the icons down here. So like I said, that is going to be yet another usage of our template pattern. So inside the recipe template, let's create an empty game object. Call it the icon container, and then inside that, let's make the template, and template is just going to be an image, so we can just create an image straight away. Call it the ingredient image. Let's scale it with a size of 40 and 40. Let's put an image by default, just like that. And on the icon container, let's put the width of 0, height of 0, and let's put a horizontal layout group. Put it over there on the left side, and we can create a bunch more just to see how it looks. Okay, so that's pretty much it. Now over here on the single script, let's add a serialized field, private transform for the icon container, another one for the icon template. Then we do the same thing as usual. So when we set the recipe SO, let's first of all clean up the container. So let's do a for each transform child in the icon container. And if the child is the template, then we want to continue and ignore it. If not, we want to destroy the child.game object. Okay, so that's the cleanup. And then let's do a for each kitchen object SO in the recipe SO.kitchen object SO list. Second through all of this, let's instantiate our icon template. Instantiate it inside the icon container. So this is going to be the transform for the icon transform. Then as usual, we need to go into the game object, set active in order to enable it. And also let's go up here, make a private void awake, and on awake the icon template game object, let's disable it. Okay, we don't want the template to be visible. Okay, so we instantiate the template, we set it as active. Then since this one just has an image, we can just do a get component of type image. That's image, not image conversion. So image, so it's this one, the one inside Unity Engine.ui. So let's get this image and let's modify the sprite and set it to this kitchen object SO.sprite. Okay, so that's it, that should do it. Let's test. Over here in the editor, let's just go into the template. Let's drag the container reference and the template reference. And let's also rename this instead of ingredient image, put icon template just to be a bit more clear. And we can get rid of the other ones or leave them, doesn't really matter. Okay, great. So let's hit on play and see. And yep, right away it does work. So we can see a burger is composed of a burger and a bun. A salad, yep, there you go, some sliced cabbage and sliced tomatoes. Then cheeseburger, same thing as the burger with some cheese. And then another burger. Let's just deliver until we see the mega burger. So let's deliver a cheeseburger. Let's cut it. get this, get some bread, place it in there, pick it up before it burns. That's a cheeseburger, so that one should vanish. And yep, there we go, it does vanish. Let's see if something else, not a cheeseburger, so let's keep doing until we get the mega burger just to see that everything works. So let's deliver a regular burger. Okay, now let's deliver a regular salad. Okay, just pick up like that, and drop it. Okay, let's see. And yep, there it is, the mega burger. Alright, great. So the visual logic is fully working and the delivery logic, all of it is working. So I can deliver the right recipes and get rid of them from the recipe waiting list, and more are spawned every time. Here we can see the name of the recipe as well as all of the nice icons. Okay, so with all of this, our game is really taking shape. Everything is very close to being done. One massive thing we're still missing is an obvious one, which is sound. So let's do that in the next lecture. Hey again, quick intermission. You're almost at the end, so once again, congrats for making it this far. This is the second secret callout. Go ahead, post in the comments a timestamp and a nice monkey emoji. It will be fun to see how many people make it to this point. By now you already know about the website. I hope it's been very useful to you. And you already know to ask any questions in the comments if you need help with anything. So all that's left for me to say right now is thanks for watching the course so far, and I really hope you've already learned a ton. There's only a bunch more lectures until we get to the final polished game, so let's continue on the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add some audio to our game, starting with a really nice music track. Okay, so our game is already looking pretty good, but everything is still way too silent, so let's begin by adding some music. Adding this is actually extremely easy to do. In the included assets over here inside the sounds, we've got a really nice music track. I hired the musician to make this, it sounds really good. It's a seamless loop, so to add to our game it's going to be super simple. We just want a constant, never-ending loop. So let's begin by creating an empty game object, call it the music manager. Let's reset the transform, keep things organized, and let's add a component, and we want the component an audio source. Here it is, this one. Like the name implies, this one acts like a source of audio. You will note how by default on the main camera, down here, it already has an audio listener. So the source plays some sound and the listener listens to it. Now over here we just need to set these fields. So for example on the audio clip, let's make sure to drag the music audio clip. Okay, great. Next over here, let's enable play on awake. We want it to start playing right away. And for this track, we do want to enable looping. Okay, great. Then for priority, basically Unity has a limit to how many sounds can be played at once. If you play too many, then some sounds won't play. And which ones do play is all based on priority. We always want the music to play, so let's put this one on max priority. Then for the volume, later on we're going to make a proper option screen to handle this. But for now, let's put it on something like 0.4 or 0.5, just to make a nice background track. Then we have here the spatial blend. For this music track, we want it to play the same regardless of where the camera is. So let's make this all the way fully a 2D sound. Okay, and that's it. We don't need to play around with any of the other settings. And just like this, if we hit on play, and yep, there's the music. Now if you're not hearing anything, make sure that on the game view, first of all, that the game is actually selected. Make sure the scene is in focus. So over here I can move around so the game is in focus. Then on the game view over here on the top right corner, make sure this sound icon is toggled. If not, then everything is muted. And also again, make sure, like I mentioned on the main camera, that it has the audio listener component. With all of that, yep, you should be able to hear the music. Now this song is playing and it will loop forever just like we wanted. Personally, I really like how it sounds. I'm really happy with what the composer made. It perfectly matches the vibe of the game. So it really is this simple to add some music to the game. Let me just point out one thing also related to sound. One of the things you can make is an audio mixer. So for example, on the project files, let's create a brand new, and let's find over here the audio mixer. So there you go, here is an audio mixer, then you can double click to open up the audio mixer window. And then over here you have the master node, and then you can create multiple groups. So let's create a brand new group for something else. And then you can play around over here with the effects, with the volume, all kinds of things, all kinds of effects, everything. Then for each sound where you have the audio source, over here note how you have an output. And for this output, you can set it to play on the master, so it plays on everything, or set it on just one individual group. So with this, you could assign a group to one individual type of sound effect or the music or so on. Maybe you could even have your music split into multiple stems. So there's lots you can do, but for me, I'm not an audio engineer. Audio is probably the part of game development that I know least about. I just stick with the absolute basics. But if you want to learn more, definitely look into the audio mixer. This is an extremely powerful tool. But like I said, for me, I don't know how to work with it, so I'm just going to stick with the basics. So on the output, let's revert back into none, close the audio mixer, and get rid of this. And there it is, the music is playing, and it all sounds really nice. Alright, so here we very easily added some music to our game. This lecture is actually super short because it is genuinely that simple. Now the next thing that we need is going to be a little bit more complex, and that is adding sound effects. So let's do that in the next lecture. Hello and welcome, I'm